It's like 11:28.
It is 11:28.
All right. And this is LANA. And we're doing final demonstration and presentation?
So, I guess
Or at least we're doing final demonstration.
I have these for y'all.
All right.
For when we get to the test portion.
Okay.
Oh, yeah, very good. Sir.
I'll come a little bit later.
All right, let's kick off. Welcome, obviously. It's our final demonstration and a heck of a presentation. So, buckle in.
Looking forward to it.
And let's,
We agree.
yeah. This, I won't promise this will be short. Yeah, we can go ahead, we're LANA. Meet the team. This is us. I'm Luke Kindlin, project manager, hardware engineer.
Tabitha Moore, systems integration engineer.
I'm Jacob Rickens, test engineer.
I'm Mary Cadena, software engineer.
And of course, Dr. Morgan, as our sponsor, faculty advisor.
Doesn't say class of 80 though. So.
Class of 80, yeah. Yeah, and here's our presentation overview, introduction, problem statement, concept of operation, functional requirements, performance specifications, CVD, mechanical design, with a lot of detail, and functional block diagram, as well as final schematics, PCB layouts, software design, test plan walkthrough, a break for demonstration, and then a conclusion.
Okay, so normally we go do the demo to make sure it works before we spend time going through all of this.
Are you sufficiently aware of what would be in the presentation?
Well, again, it's your process, but
Yeah.
we want to make sure that the system works, i.e. the demonstration,
Right.
before we spend hours going through the presentation.
I think that makes.
So are you ready to demonstrate and show us through your test plan?
Ready to demonstrate?
Well, let's go to the functional block conceptual block diagram.
Yeah.
Just make sure we know what we've got.
Okay.
Okay, so
There we go.
of course we're going to start with our standard wall outlet, plug in our ADC converter. That'll do 12 volts. We're plugging that into our interface board. I can do it. We're plugging in our wise cams for 5 volts to the interface board. Okay. 3.3 volts to our CC3200. That's going to take 3.3 volts to our BoostX cell pack, and that's going to communicate back with I2C. We're also going to have two PIR sensor and a water level sensor that's being powered from the interface board, both with 3.3 volts, digital in with the PIR sensor and analog in with the water level sensor. And then the CC3200 communicates to I2C to the interface board. So over here we're going to have 8 ports total. We're going to have 4 low side switching modules and 4 H-bridge modules. These are examples of what we're using them for. For our H-bridge modules, the only thing we're using it for is our control lights. We have a whole host of low side switching, which are mostly servo motors. We also have an on-off switch for our heat lamps. And that's going to send 2 PWMs, 2 voltage lines, and 2 ground lines.
Okay, did you say stepper motors?
No, that says control lights.
No, up on the other one.
She said servo motors.
Servo
Okay.
motors.
Yeah.
Yeah. We also have our, for each port, we have a jumper switch, a little bar switch that'll let us control 5 volts or 12 volts that we're sending out on our voltage lines. So this here is showing that we are directly connecting the CC3200 to our interface board, and all those extra pins come through, and we're sending them out, along with an extra voltage pins and extra ground pins. We are directly powering our hotspot with an interface board with 12 volts. And we have a Wi-Fi module on our CC3200 that communicates 802.11 to our hotspot. The WiseCam does that as well. And that sends 4G wireless to the cloud, which we're using Cayenne.
But the video is not going to Cayenne, right? Does Cayenne have any ability to process or display video?
No, not at this time.
Well, and the WiseCam doesn't have the ability to use anything but their app unless
Yeah.
you actually take a stored video and download it.
Right.
Um, Yeah, but Cayenne keeps adding devices.
Yeah,
So I can't believe they're not gonna end
So
up.
Cayenne is actually refusing, has not refusing. Cayenne hasn't allowed an app yet on just your laptop that you can use to monitor a Cayenne camera.
Yeah,
I found that kind of frustrating.
Or Wisecam.
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 Yeah,
You
Wisecam.
can't access it on.
You have to have like a
laptop.
tablet or
Yeah,
something.
yeah, it's gotta be on a phone
Yeah.
or a tablet,
Yeah.
Android or iOS only.
So here's that set up here, and then here's our house.
Yep.
I have one in each room, and this one is simulating the one that's going to be in the basement. They all communicate to one hotspot that sends it 4G wireless to the cloud.
Okay, go back one. And each room now has a camera, and it's
Yes.
shown.
Yeah, so each room has a
Camera,
camera,
camera.
and there's also the one that's outside the room. It's not in the basement, it's outside.
And it's powered from the basement.
Is that one powered?
This one's
Um,
just
this
powered
one?
to
Yeah.
Yeah, it's just remote, so it's directly from the
It
wall.
could be plugged in though. We have one
Okay.
of them.
Yeah,
Okay.
if we wanted to, it can.
I'd like to go over the mechanical one, the next slide, just so we understand. So here's our an outside view, and then here's an inside view. Next. So here I would label the walls. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if we're referencing walls, in general, this is the layout.
Okay.
I'll tell you that again. So as far as our roof, we have it divided in half this way. There's metal on one side and shingles on the other. And then for the insulation, we have it divided the other way. So you have insulation on this side and no insulation on that side. So you have
And
4
that's
different
in-
zones.
Basically, we're directly
Yes,
under
that is
and
directly-
on a slant, right?
Yes.
Okay.
Exactly.
Okay. So then we have 4 different zones, and that's what I wanted to go over for the mechanical.
And this is being videotaped?
Yes, it is.
Yes, it is.
And demonstration? Unless y'all want to go over anything else, we can go ahead and do the demonstration now.
Let's go see the demo.
Let's do it.
Granddaughter, what's her name?
Melina Willie. Automated machine
No.
folded.
Yeah, they don't make in the convenient timing those machines.
Yeah, so this is a little.
So you hand folded?
I did, yeah.
Well, I'm not gonna complain about the alignment, I'm gonna say good job.
Thank you.
So Luke, this Friday
Yes.
at approximately 11:45, Dr. D. Miranda, who is the department head for teaching, learning, education, preparation, or something like that.
I've seen his name.
Well, he's the mentor to Michael.
Okay. Oh, perfect.
Okay,
That's where I saw his
Michael
name. Okay.
Is going to come over here to meet with us, and my plan is to take him to lunch.
Okay.
Will there be anybody here?
What time did you say?
11:45.
11:45 will be fine, I've got another final demo coming up at noon.
Okay, what I'd like to do
On Friday, you said.
on Friday is to show him this facility.
Yeah,
And
that
a
would
very-
be fantastic.
15-minute kind of operation
Sounds perfect.
where we're raising blinds or doing that kind of thing, just talk in general about it.
Okay.
And what you did just now would be a great intro
I
to
will
it.
be at work in Minnesota.
Well, but that,
Okay.
I'm sure,
Someone else is capable.
is capable. You're gonna trust them? Is that possible?
Yes, I've got a final at 12:40, so I can't take too long, but I can definitely do
Well, then maybe it
11:45
isn't you, but,
12 o'clock.
I have the
heavy.
same class, which
well, but you're gonna,
Yeah. He's just gonna ace it.
well, whoever can,
Yeah.
if that will work for you,
Probably
We got this. Yeah.
Okay.
Yeah,
Almost
we can make it happen.
all right. And then we're gonna go to lunch and talk about, he has, I shouldn't tell you this, but he has a new STEM education facility, a lab, if you will.
Okay.
And we've been looking for, well, where we're gonna put this.
Oh, yeah, okay.
That could be
Excellent.
where it ends up at.
Okay.
But I want him to appreciate what it has as far as capability
Oh, yeah.
before he's making that decision. Yeah.
Sounds good.
Okay,
Okay.
to be.
Right over here.
Okay.
So, if you follow along in the test plans that I put out for you. The first portion of it just goes through the functional requirements, performance specifications, and then of course there's the test matrix, and that tells us how we're going to test those. And then we have the test flow diagram, and this is stuff you'll have already seen. But the main thing we're going to go over today are the test procedures themselves. So they've all been tested and videoed, but we're going to run through them live today. If at any point y'all have any questions, please feel free to jump in and ask.
I wouldn't say that. I would say let's go through the whole test plan, and then if you have any questions or
Alright.
other things you'd like for us to do, we'll be happy to accommodate that.
So we started off with physical measurements of the model, which we can run through now.
Well, unless there's something that's,
There's not.
okay,
So I
then
have-
we're going
I have
to agree
the-
it's 4 by 8
Yes.
by 3.
So I have the test results all here.
Yeah, okay.
So
It
essentially,
contains 4 rooms,
4 rooms.
each is controlled individually.
Yeah, the window sizes, the thickness of the sheet metal, the thickness of the glass, all that stuff is all measured and tested, and it all passed.
Did you realize that those are really glass windows?
Yeah, I did. I didn't realize that they'd scaled the thickness, though.
Yeah, we have a shattered window over there on the bench that, because it's pretty thin.
But they're single pane.
They're single panes.
You didn't do the double pane and pull the vacuum between the panes or anything?
No.
Okay.
No, we did not.
Next year.
Okay.
All right, the second test is a simple test. We call it external verification. It's just to make sure that our insulation has an R value of 4, and it's as simple as looking at the board of insulation, and it has stamped on there the official seal, R value of 4.
Okay, and we have insulation in the roof,
We do.
and then there's insulation between the roof assembly and the house?
We
or-
have that board right over there behind Luke.
Okay.
Over here.
It can be put in.
Yes.
Can be installed. We had it installed all day yesterday like that.
Okay.
We were testing and stuff.
But the roof will fit back on,
Yes.
Yep, lifts
Okay.
right up.
so there may be some value in having that,
Yeah.
even though you have insulation in the roof.
Oh, yeah,
Having
sure.
additional insulation.
Exactly. That's
Okay.
why we kept it 4 by 8 so that we could have that option.
One of
Okay.
our functional requirements was to have removable insulation, and that's in this wall over here. So if you see,
Was that used to be over here? Yep.
Yeah,
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 rotate
we
it.
spun it around because we wanted the HVAC on this side.
we call it our mobile home.
Yeah.
So that's right in here. So it doesn't quite open
Yeah.
all of the
Hop
stuff
around the
around
corner.
here. I mean, you could.
Yeah, and each one has its own
Each one
gizmo
you can
to,
pull out, just like that. You can see straight
Okay.
through.
Okay.
When you hit it with the thermal camera and it's cold inside, you can see exactly where the insulation's missing. It's really cool.
where did this thermal camera come from?
It's on loan from David Malloway.
From the ETID department.
Is it one of the ones that goes to a cell phone?
Yes.
Yeah, it plugs right in
Yeah,
the bottom of your
okay.
cell phone and
But I hadn't thought about that.
it's actually right here.
That's
It's tiny.
Yeah, but
About 200-300.
getting a small form factor thermal camera
oh yeah.
Yeah.
that could be internet connected.
Has value.
Yeah,
Yeah.
yeah.
So that's how you remove the wall.
Yeah.
So
Got
we
it.
remove the
Got it.
wall panel and the insulation. And the insulation again has an R value 4. The next test that we did was.
I thought there was supposed to be a front porch.
was,
won't fit
a
through the door that
rocker. Yeah.
That's the table, is that?
Yeah.
The next test we ran was a power test on the board. So we took the board out of the living room. We put a multimeter across the test points for the voltage regulation and made sure that it was correct. I have the results. If you would like me to run through it now, we can do that, but it requires taking the board out and everything.
Okay.
Good report. All right. The fourth test was a set temperature test. So this essentially was where we take cayenne and we set the temperature in one of the rooms. I can bring this over here where there's a little more room. where we set the temperature in one of the rooms, and we monitor it as it rises to that
Okay,
temperature.
I know you're gonna get to that, but I just want to get a feel for this. Aubrey, give me,
Can I run through
Yeah,
real quick?
just-
You go through it.
So, this is room 1. That's the largest room in
Okay.
here, the living room. Let me go ahead and just close this up so that we can see it. So here are
okay.
all the different rooms: room 2, room 3, room 4, and they go in from largest to smallest. And then the HVAC
Okay.
is down there.
Yeah.
So here, if I let me
Is
just-
each room have essentially the same layout?
They have the exact same layout, but some rooms have more windows than others, so there's only a slighter difference of.
Okay.
But here, so it got cut out, but you can see that it's the door lock. Here you have the motion simulator, which is our flag that it's inside. The B indicates an energy mode, and that just increases your set point to 78 when you're not at home.
Okay.
And you can't increase or decrease the temperature when it's in that mode. Here, these are 2 indicators telling you whether it is too hot or too cold inside the room. You have a water leak indicator and a motion indicator. You also have
I thought this was motion. That's the flag?
That's the flag, and this is the PIR motion
Okay.
sensor. So then we have the air vent indicator that just tells you if the air vent is open or closed. You have your window blinds. Here's window blind 1 and window blind 2, and then you have lights and lighting 2. These numbers indicate the channels for
Lighting
programming.
1 and 2, what is that?
So lighting, there's 2 LED strips on each end.
Oh, okay.
And you can adjust their dimmable, so you can increase or decrease them depending on
Okay.
what you want. So here we have the relative humidity as a percentage, the lux value inside the home, and the pressure inside the home. And then this is to manually operate the vents.
What is 1,000 pascals? Is that?
I think that's 1 atmosphere.
Yeah,
Is
it
that-
is.
That's what
That's right.
Okay.
It's just about sea level,
Can
which
confirm.
is we're just a little bit above that.
300 feet.
Yeah, here.
So that's our quick rundown.
And
So this is just to manually operate the air vents. If we're heating, we could open it.
Okay.
Deal. But
okay.
that's just a quick overview.
Now back to
Alright, so essentially what we're going to do here is just prove that we can set the temperature and control the temperature in one of the rooms. We're going to do room 1, which is the big room right here. So what I'm going to do is I'm going to go, just following the instructions in here, I'm going to go to the HVAC module here, and I'm going to turn the heat off and turn the cooling on.
and that's all being done through your Arduino.
Exactly. Something talking to another something.
Yeah.
And then we're going to go back to HANS room 1, and we're going to take it off energy mode. The current set point is, it'll update in a second here,
It needs to update.
yeah, it's 77, alright? So it's at 77 degrees, which according to our functional requirements is the max temperature range. We can go higher than that, but our functional requirements stated that 77 was the highest that we needed to go.
God, that was a long time ago. We decided on that.
Yeah. So I'm now going to decrease the temperature set point to 67, and
Where are you doing that?
so I'm going to hit the decrease button
okay.
here,
Okay.
and the set point is going to change over here.
Got it. And we're dropping.
We are dropping, and you see the temperature is already falling in the main room.
Summertime.
Motion on the air conditioner.
Yeah. And the vent opening.
It sees that?
Yeah.
It does.
You can see a lot.
All right, so the set point is now at 67, and just to verify, you can walk over to the control panel on the AC, and it is cooling. There are 64 degrees coming out.
Does it go to max cool no matter what?
Yes, if you want cool, you want all the way cold. It's like a binary system where the AC is either on fully or off fully.
Okay.
So setting it to 64 ensures that it stays.
And our
on
vent
full.
can only be on or open or closed?
Correct.
So when you turn on air conditioning on AC, Does the AC run continuously even if all the vents in the house are closed?
See that one time?
If all the vents in the house are closed,
Right. The AC will continuously be running.
the AC will continuously be running.
Yes, sir.
And you don't have any place to vent refrigerated air to the outside world.
We do.
You do?
Yeah, we have a dump vent.
Okay, so do you run the dump vent when all the internal vents are closed? What do you do with the dump vent?
So right now it's just manually controlled.
Okay.
Because it wasn't ever like a performance or a functional requirement, but that dump vent is currently it's open slightly, just to relieve some of the pressure from our testing last night. But we can run it fully closed, fully open. If it's closed,
Well, that would be an interesting experiment
then
for
it's
the,
a closed loop system,
Yeah.
which is
for the high schoolers, because my
very-
guess is that if you have the dump closed, all the internal vents closed,
yeah.
then you will eventually freeze up the air
You
conditioner.
do.
Oh,
Within
you
like a
demonstrated
minute and a half. Yeah. We didn't demonstrate.
Excellent.
Well, we've done it several times.
Okay.
Yeah, and it freezes, and it knows that it froze, turns itself off,
Oh,
runs
interesting.
dehumidification on itself, and then starts up again.
Well,
So
isn't
it has
that
a-
handy?
Yeah, it's
They didn't do it.
It's cool.
The air conditioner.
parts
I'd like that in my air conditioner.
Yeah.
So when you switch from one mode to another, there's a pause that you have to. It's normally 3 to 5 minutes.
So what is the,
So it's coming down to 7.
okay.
So it's already dropped 7 degrees. It's at 70
Yeah.
degrees. You see up here.
Uh,
If y'all
what
would
just
like,
happened?
we can.
Sounds like it might have froze actually, because the dump vent might not be fully open.
And also our other rooms have a different set point, so most of them have already been closed.
Okay.
And that's mostly why it got closed.
It's saying that the return air is 64 degrees, so the AC is going into protection mode because it's getting too
Even
cold
though
there.
we haven't,
The temperature's
so
still
it's the
dropping.
temperature sensor that's not responding as quickly.
as quickly as the air that
As the
comes
air.
right back out of the system.
Okay.
So if y'all would like, we can wait for it to drop to 67. Otherwise,
we'll
we've
believe
tested. We've tested it
Yeah.
already.
Well, it's already at 69 too.
Yeah.
It's-
Yeah. So
Yeah,
that
I
was
will
needed
believe you.
just
That
about
that
4
seems to
minutes.
work.
So what we've done is we have way over spec'd our air conditioning for.
It's oversized.
Yeah.
Yes.
Yeah.
It's meant for a much bigger space.
Yeah.
Right. It's the smallest one that has heating and cooling in
Cooling,
the same
yeah.
window.
Yeah.
So.
Um,
yeah.
But it's something we know and we can live with. If you were to build that house, you wouldn't put that much air conditioning into there.
Or you might use the same air conditioner for a half-scale house.
Okay.
That would fit.
All right. So that's our test number
And this
4.
capability exists in each room to independently set temperatures.
Yes, sir.
How much variation have you actually been able to create? You know, in my truck, I can have the passenger 2 degrees different than the driver,
Right.
is about what they say
Oh,
my
and
variation.
the driver
is.
and then the
Yeah.
side.
Yeah.
So
the whole house started.
currently we're reading 73 degrees in room 4, which is this room right here,
The furthest room from.
and the other room is at 68 degrees.
Is there insulation between those rooms?
No,
There's
there's not.
Just like a normal house.
Okay.
So we currently have
Now, wait a
a
minute.
5-degree difference.
Well,
I
not
have
a normal
interior
house.
walls.
A normal house.
An average house.
A spec house.
Yes, yes. So we have currently a 5-degree difference between the 2 rooms,
Okay.
which is pretty big for
That's
small
good.
space like that. All right, so moving on to our 5th test, which is the control LED test. We're just going to open the door real quick, and what I'm going to do is I'm going to unlock the
Let
door.
frigid air come out.
Yes, I'm going to unlock the
Oh,
door
you put your hand in. and-
so that I can open it so y'all can see the
Okay.
lights inside.
Just unlocked.
Yeah,
Actually,
if you wouldn't mind opening the door.
could you show me a lock?
Yeah, I
Just
can go ahead and show
kits?
you the lock. It comes a little later in the test program. I
Okay.
guess.
Yeah, well, we'll look
I
at it
think
when.
it's just cool to see.
So it goes there, and then unlock it again. It's pretty instant.
Oh, cool.
All right, so in room 1, there are 2 strips of LEDs that are on the both top corner of the interior walls on this side and on that side.
Okay.
So I'm going to turn one of them on. on full brightness.
Yeah.
Far wall, and I'm going to turn the near wall on full brightness now as well. Then I
Can you see using the IR capability of the camera when the door's closed, the blinds are closed? Can you still see things in the room, or is that just beyond its capability?
I haven't seen that, like see-through walls kind of idea. It sees the wall.
No. Just can I
So,
see inside? Can I see
enough
features?
inside the house without the lights on and the blinds closed?
Is the camera working?
That's a good question. Let me plug the camera in. It's kind of finicky because
No. I'm just talking about the regular camera
regular
inside.
camera
Interior
inside.
camera.
Yeah. The
Yeah,
last
yes.
camera goes.
You can see.
All the walls.
Even with everything closed up,
Everything's-
there's enough light there that the IR
Oh,
allows
yes.
me to see what's happening. Okay.
Yeah, and the IR has its own, what the circular ones have a couple IR LEDs inside of them that shine out,
Yeah.
actually, so it's super bright. And it automatically goes night vision or
Yeah.
full color. Yeah,
So-
we'll show that a little bit later.
And then I can put them both halfway, and then all the way off. So this is halfway.
Yeah, and you're getting good variation in intensity because you're at 60 hertz.
Right. Yeah, that's still a nice
Yeah.
chunky.
We're gonna try that on Hermes and see if it helps at all.
All the way off. Alright, so
And
that's
lights are in each room?
Yes.
Yes. But this is the only one with 2.
No.
No,
Our second room has 2 as well.
bigger room, more lights.
Okay.
yes, sir.
Okay.
So that's the proving that we have control of the LEDs inside the house. The next test we're going to go over is the motion test. Essentially what we're going to do is we're going to trigger the motion flag, which is the actual flag, inside the room using Cayenne.
You got a Texas flag
Yeah.
as opposed to an Aggie flag?
I couldn't find Aggie flags in that size, and I
Okay.
didn't want to use an American flag.
Yeah. So
Why?
It felt disrespectful in some way.
But not to the Texas flag,
Texas
apparently.
flag, I'm not from Texas, so.
So you could disrespect the
blind spot.
Okay, that's.
I do not. So
That's
condone
minus
the-
3
I do
points
not
right there.
condone
There you
the,
go. It was
the opinions of my.
Yeah, it was not a team
Project
decision, it was a
manager.
Luke decision.
That was very true.
So what I'm going to do is I'm going to trigger the motion sensor here with the simulate button, and it's going to move the flag inside, and then I'm going to watch this widget right here, which as y'all have seen is pretty sensitive. It will detect when the air comes on and stuff like that, which is on the inside of this wall, pointing that way.
Okay.
So I'm going to simulate the flag here. You can see it through the door,
Yeah.
and
Oh, that does both directions when you click that? It's
It
not
does.
bring it up?
Correct.
And then bring
Yeah,
it
it
down?
moves it back and forth.
Okay.
sorry, and you saw it detected the motion.
Did you see that?
I did not see the flag, the
We'll do it one more time.
Purple.
Does the
You're sure?
Can you refresh the page?
just
I'm going to refresh it. I'll just make sure.
How long does it stay detected?
3 seconds, and I send every 5 seconds, so we could have missed it at that time. You want to go ahead and actually just let it.
Not do it.
No, just go ahead and let it.
There it is.
Okay.
We have the video.
So
information.
how can you fix that?
It might be the location of the PIR sensor. And the location of the
What I
flag.
can do is I'm sending data in 2 sets. One of them doesn't include the motion. So if I include the motion in both sets of data, like I do with the temperature set point, you'll get it within no later than 5 seconds. But in my case, if it misses that one set, it'll have to wait 5 seconds and then 5 seconds to get to the
Yeah.
other side. So that's why we missed it in this case.
And it's not a matter of the flag waving.
No, well, I don't.
I mean, if I made the flag do it twice,
So just for grants,
Like do a chop, chop,
we've
chop
done
or something.
4 or 5 flaps of the flag, that hasn't done. Let's try sticking an arm in there a few times, and let's see how reliable that is on the
Okay.
back.
Okay. So I'm gonna stick my hand in. Okay.
Did you do it in front of the sensor?
Yeah, that detected it?
Yeah. So I detected it right there.
Okay, so let's go by.
See how long it takes to go down.
Because there may not be enough of go ahead and do it again. There may not be enough of an IR temperature delta on that flag for it to reliably be seen by the PIR.
Especially with the room cold.
Yeah.
How cold is it right now? 70?
It's 70 degrees.
Did it not hit?
Didn't hit that time.
It's in the wall right there. Yeah, you were going straight in.
Yeah, I think you need to add it to the messages.
Okay.
Yeah.
Yeah.
Well, we need to send them more frequently.
I'm just gonna go ahead and wait for the.
There you go.
There you
So
go.
it went on.
Okay.
So I think the idea is that practically, if there were a person inside,
Yeah.
there would be movement for a longer, sustained
Right.
period.
But you're
As opposed to
definitely
just a
missing
single flag.
events,
Right.
which
Yeah.
you could reduce the amount of misses by
5 seconds.
adding in.
To both.
Okay, so you're taking that action to correct that. Okay.
Sorry.
Okay. Keep going.
All right. So that's the motion test. And then moving on, the next test is the door lock test. We can run through it briefly.
We already saw it.
You already saw it though. Moving on, so that's test 7. Test 8 is the window shade control. So the
All right.
blinds on the windows. Now I'm going to use the blinds on this room right here, which is
But you
Room
checked
two.
every room.
yes, which is room 2. I have checked every room.
You can go through them all if you'd like.
We can. Right. So room 2 has 3 windows. This one, and the one here on the other side. And I'm just going to run through all
So
of
how
them.
do you know which one's which?
So
One,
like-
two, three.
it goes 1, 2, 3
Okay.
on the windows. Here's window 1, which is on this side. So if you see
Okay,
the blinds
yeah.
just opened. Window 2 is this
Can
one.
you take it halfway?
Yeah, make
Yeah.
window 2.
Well, I was gonna do it on window 2.
Yes.
There you go. Okay.
And then I can take window 2 halfway. And then all the way. And window 3, the same thing. And then all the way back down to the original position.
Hey, Frank. We got a little house here we're
Yeah.
put on the market.
Very impressed with that, by the way.
You are?
Absolutely.
If you can impress Frank, you have done something. Your presentation's done, we don't need any more.
Sorry, All right. And that's control of the window shades.
So, how do I build the capability to adjust the shades based on the internal lighting?
So
That's not capable right now,
No.
And
but
it's
I
not a
could
functional
build
one.
that module into Cayenne, right?
Right.
So that it's constantly looking at my lumen
your lux, or your
lux,
luminosity.
yeah,
Mhm.
and adjusting the blinds.
The
to-
blinds, I'm sorry, I'm just thinking also about the lights. So I'm guessing if you're only wanting the blinds, then you can do it that way. I guess it could get trickier if you're using your
2 variables.
inside LED lights. 'Cause
Yeah,
then you're adding another
yeah.
variable
But
to that. But yes,
That's the kind of thing that we might have high school students do.
right.
Is
Yeah.
that possible?
It's definitely
Oh, yeah.
possible. Yeah.
Okay. And to have a 2-variable input where I guess I would want to adjust the blinds to their maximum amount of lux.
Mhm.
If I couldn't get it with just blinds.
Right. You would
And then
also
move-
probably have to
Yeah.
also want to increase the lighting if it wasn't reading.
There you go.
Catching your set point. So yeah, that would be even.
And that is based on your knowledge of Cayenne.
Definitely possible.
And your value indicating you will not be passing 420.
It's definitely.
You sure you don't want to change your mind on
And then
it?
you have to put a calendar function in so that when you catch the time change and it gets dark at 6 o'clock at night, then, you don't open up your shades and let your neighbors a full view.
Well, my son is actually downloading the calendar, determining where the sun is and adjusting the blinds based on.
Tells you what the temperature is, so
Mhm.
let's see, the face should be around 80-ish degrees, something like that. Yeah. So it's pretty accurate.
You're alive.
You're
Not
alive.
dead.
But check
Yes,
Frank.
yes.
Check Frank. I've always wondered about him.
See how hot your coffee is.
I know he's cold-hearted. I didn't know.
Oh, make my.
Professor Willie is not a zombie.
Okay.
So,
what are we gonna do
What we're gonna
now?
do for this test, the functional requirement is that we can heat the shingle portion of the roof to plus 10 degrees of ambient temperature. So what I'm gonna go ahead and have Luke do is I'm gonna ask him to measure the temperature
A little bit closer.
of the roof now without it on it.
So right now it says 69.7 degrees, 69.4. It's actually falling because it's so cold in here, and it's uninsulated between here and here. All your cold air is just leaking.
I thought cold air dropped.
It's supposed to, but it's like a freezer in here.
Yeah, it's pretty cool.
So
Seriously, it is?
It's really cool.
I gotta check this.
yeah, stick your arm in.
Keep your coffee on the outside. So the functional requirement is specified previously is that the heat lamp only had to be a physical on-off switch.
Yeah.
However, we have ability to do it through Cayenne as well.
So nice bonus.
So I'm going to go ahead and we're going to go
Again, they
to.
didn't do a damn thing.
Yeah, I know.
So
Other than buy a piece of art.
so I'm going to move down to
I'll move this a little bit closer.
the basement board, which is where we control the heat lamp.
Yeah.
And he said it's resting right around 69 degrees. Yesterday we got it 10 degrees in about 4 minutes, so we'll see about how long it takes. So I'm going to go ahead and turn the heat lamps on using this right here.
Make sure it's too flexible.
Alright.
There we go. Shot. What was that?
No, the AC is on automatic.
Do you want to close the door?
So, yeah, I'll close the door. So this is actually a more
But
rigorous
do
test.
you want to have the air conditioning on if you're trying to measure? I guess all you're doing is measuring the
The surface of the roof. So this is actually a harder test, I guess, than we need to do.
It is.
Because this is hot Texas day, sun, your AC's pumping.
So Luke, if you go ahead and measure it on that hot spot right there.
Let's see it. Let's see it. I can't make it out. It's very well. My eyes are bad.
So I'm gonna hit the record button so that y'all can see it as well. But it says 84 degrees right now.
That came quick.
So in that hot spot right there, it's 115.
Real. Careful. Yeah, it's 1,000 watts. So
So we'll
it's
go ahead and play
Where
back
do we
this.
think the hot spot is?
Ooh, real bad. It's pretty hot.
So we can watch the recording that I just took. I believe. Should be able to use this. Here we go. So, and there you see the reticle moving around. It's at 105 degrees, 113, 16, 17. So it heats up.
So we're gonna
pretty quickly.
need this to be controllable via Cayenne so that remotely they can.
Yes,
They
sir.
just did.
It
So that was the idea.
No.
Oh, that thing.
Oh, that
This.
thing.
yeah. Oh yeah. Like yeah. Shoot.
That is not a requirement. So since we already exceeded the plus 10 degree
But we
temperature,
could put some
I'm gonna
kind
go
of
ahead and turn
temperature
the lights off.
sensing into the ceiling by just replicating and having an attic controller, right?
Potentially.
In fact, we don't even need, other than power, we could do that all just with a launch pad and a plug-in Boost XL, right?
Yeah,
We could.
some are extra IO.
You probably wouldn't be able to get the surface temperature of the roof, but you would know the
Like a
temperature.
little,
Well, you've got
like
two
those
different temperature sensors, right?
dudes that plug into a,
Okay.
That would be interesting, to put in a scale and a vent, and be able to turn the turbine on and off.
Now,
See
you
what the
think that,
effect is, yeah.
So that's test 9. Test 10 is testing the ambient light sensors in room number 1. So what we're going to do is the room currently, the lights are off and the blinds are closed. So we're going to take a note of the reading where it stands, which is at 9 lux. And then I'm going to open the blinds and turn the lights off, and you're going to watch the lux value
how many
rise.
windows?
It has 2 windows.
The
Two
two big
windows.
2
windows.
big windows.
Okay. So,
So I'm
Out here, last night it was about 550, and standing right here
Yeah.
under one of these
Okay.
lights.
So, for context, inside the room, when the lights are on and the blinds are open, it'll normally get up to around 80 or 90 lux, simply because of the way that the light radiates down and there's a roof on top. So, that's still quite well lit enough to see normally. So, I'm going to go ahead and close the blinds, and we're going to see the value rise, and then I'm going to turn the lights
You're
on.
gonna open.
Open the blinds.
Excuse me, yes, open the blinds. We're going to see
We're
the value
listening.
rise.
We're listening.
And then we're going to turn the lights on after that.
and how fast acting
Oh,
is the
excuse me.
lux
That was the light.
sensor?
About just as fast as the motion and the water. It's also
limited by
saying in
Cayenne,
2 cents.
not by
Yes.
us.
So we're
The
gonna.
sensor
how
readings are
fast is the
that
sensor?
fast.
I'm sorry.
So it went up from 8 lux to 31 with just the windows open.
Okay.
Now I'm gonna turn the lights on.
And you said this is 550, normal room lighting.
He said
This is
fine.
considered harsh, actually. Yeah. So like this is
Okay,
like
and
what
what's
an architect would use.
outside direct sunlight?
It was it was at 1,000 plus.
1,000?
Yeah.
Okay.
All right. So I'm gonna go ahead and turn the lights on.
Pretty bright. Nope.
You can
I
see kind of through the cracks.
Kinda see it.
Yeah.
It's a feature.
And what do we get up to?
We're about to find out. 182 lux.
Oh, okay. You got okay.
one small one.
Is it okay if I open the door?
Yes, sir. It should be unlocked.
Quarter scale.
Where is your light sensor in there?
The light sensor is on the floor on the
floor?
Right in the
Right
middle
in
of
the
the room.
It's on the Boost
Right.
XL.
Okay. Put everything.
Okay.
And that's the ambient light sensor test, test number 10. So I'm going to go ahead and close the blinds again and return it to the original position that we had it in. Alright. Our next test, test 11, is our ambient temperature temperature sensor test. For this one, what we're going to do is we're going to look at the reading here for room 1 of the temperature. The temperature says 69 degrees, and then we're going to look at we bought just a third-party little digital monitor on the inside. It's called AccuRite. It's accurate to about 2 degrees Fahrenheit, and our sensor is accurate to 2 degrees Fahrenheit. So the total range is 4 degrees, which is within our performance requirements. Functional requirements. So I'm going to go ahead and it says 70 degrees in room 1. We have experienced with the AccuRite sensor that it takes a little bit longer to catch up to the temperature difference.
Is it already in there?
It is already in here.
Yeah, it's already.
It should
Actually,
be.
the drapes aren't open quite yet.
So I'm just going to open the door. It's right here. So it's currently reading 68 degrees on the interior,
Tolerance.
which is within tolerance.
Yeah.
That's That's essentially just verifying that the
And that's,
temperature will be.
does that have an external wireless module too? I've got one that I keep in my house, but there's one outside.
There's more modules, like, this one isn't, this is an all-in-one.
Okay.
It
This is a
reads
very-
relative humidity, and as well as temperature, and it's just one little thing, AAA battery.
No wireless
Not
wired.
this, the one next to it was,
Yes.
yeah.
So that's test 11. Test 12 is a humidity sensor test. Using the same concept, we're just going to observe the reading here on Cayenne and then look at the reading on the AccuRite module inside. So here it's reading 45% relative humidity. And on the inside one I just checked, it was 40.
It's 40,
And the
which is
tolerance range is plus or minus 5 degrees. For
5%.
5%. Yes.
Oh, wait a minute, how much is it?
Plus or minus 5% relative humidity.
Okay, and what are you getting?
This is 40, that's
40.
45.
So 5% of
No, no,
40
it's-
is 2, right?
It's not 5% error. It's 5% relative humidity. So relative humidity is measured in percentage.
Yeah.
So whereas you would say plus or minus 2 degrees for temperature from 45 would be up to 47. Plus or minus 5 degrees relative humidity, 5% relative humidity from 45 would be 40%.
Oh,
50%.
okay, I see.
You're mixing your units.
Plus or minus 5% of humidity, not of the measurement.
Correct.
Okay,
Because relative humidity
I
is
got it,
measured
I
in
got it,
percent.
I got it.
Yes, sir.
So, if I had one of the ones that had both an inside and outside, and that I could connect to wirelessly, I could actually make that my attic inside and put the outside one on the roof somewhere.
Yeah.
Right.
That would be a very quick,
Yeah.
easy solution to that.
I may donate mine.
There you go.
Okay.
Yes, sir. So that's a humidity sensor test, just verifying that the relative humidity is accurate.
And we did it in all the rooms.
We can do it in all the rooms. The AccuRite, the digital monitor is just in room 1 right now.
Yeah.
We can move it to one of the other rooms and check it.
Probably check it in the small room, if you will.
Okay.
Sure.
It's pretty slow to respond.
I know, that's
Compared
why.
to our stuff,
It's fast.
if a human is next to it or you kind of hover your hand over it, the sweat from your palm will raise the
I
relative
think
humidity.
you were
It's-
doing it using like your breath.
Yeah, I was
Raise
breathing
breath,
on it.
breath.
Oh,
Yeah,
The
yeah.
alcohol.
Alone.
You gotta be videoing.
Yeah.
We're gonna have to edit this video.
All right, so test
He said
13.
jokingly.
Test 13 is our water level sensor test. So there's a cup of water on the interior of the house. Right.
Do you want to?
It's still there.
Okay.
I buckered it to the wall again.
So the cup of water is right here. So our sensor can measure water levels up to 1.5 inches, and the temperature range is in here. So essentially what I'm going to do is I'm going to show that it's not measuring that the sensor's in water. We're going to dip it in the water, and then we're going to see that it senses that there's water. And it does not do varying depths.
But you said it measured water.
So it measures water levels. It detects like submersion in water up to 1.5 inches. So it measures it detects whether or not it's submerged in depths up to 1.5
So it
inches.
measures
because
the resistance between two prongs.
Yeah.
The prongs are 1.5 inches long.
Pardon me. So the sensor has that capability. We're using it as a
As a
binary.
Okay.
Is it wet or is it not wet?
But I could mount it prongs down
It is.
and be able to measure depth based on a resistance value.
Are you sending the analog value or a digital value?
We send an analog value to the CC3200, and in order to meet the needs of the ADC, we cut it in half. So instead of 3.3 volts max coming back, we cut that down to 1.6-ish.
But what are you sending to Cayenne? Are you sending a digital or are you sending an analog value?
So as soon as it passes the analog threshold for being submerged in water, we send a binary value indicating whether
Okay,
it
that was the question.
But you could send an analog.
Whoa, okay, so you can definitely send the analog reading. No, yeah, no doubt about that.
And show it on a gauge or something of that nature, right?
However, for
But
purposes
that
of our
requires
project-
adjusting your protocol, correct?
Yeah, you gotta change the
Yeah.
sensor.
Yeah.
Or the
So you
display.
can still have
Display.
it go
Yeah.
to a separate
No,
channel.
I get that.
Just give it.
I get that.
For the functional requirements for this project, it was only required to detect
Oh,
whether or not it's
yeah,
submerged.
yeah.
Just putting that in
Didn't
there.
take it.
Yeah, that's what happens when you deal with attorneys.
So, what's going to happen is the water sensor widget is right here on this little water faucet. So it's gray right now. It's not detecting any water. I'm going to take the lid off of this cup and I'm going to dip the sensor in, and you'll see it turn blue. And that's the
Test
test.
this every time.
Yes.
This is-
yeah.
A longer pulse.
And we see his,
Your motion
The
sensor.
hand motion, so not that one.
Nothing up my sleeve.
So here's the sensor right here. I'm going to dip it in the cup. And it turned blue.
Yep.
no,
I like the confidence.
no.
All right. And now that I've taken it out, normally in a couple seconds it goes.
There you
There
go.
it goes. So you don't even have to
So you
dry it
just
off
got a
yourself.
switch back there. You're
Oh yeah. Yes. Yes. You caught me.
The switch.
Get your hands out of your pockets.
And that's the water sensor. That's test 13. We have one more left. Test 14 is the camera footage test. So for this, I'm going to ask Luke if he can pull up his camera. For this, all we're going to do, the functional requirements are that we can view live footage as well as saved footage. So I'm just going to have Luke display that he can view the footage live and control one of the cameras. And then he could also go back in history and look at saved footage, which Dr. Morgan is always watching. So he knows
Oh, right, right.
This
So-
function works.
This is the living room movable camera, so you can move it around, see a live view of everything, up and down.
And my grandson were quite impressed with this.
The movable inside,
yeah.
it's just
pretty
just
cool.
cool. And then
Now, there's something I didn't know. Maybe I showed you that.
oh yeah, when you went
This way?
so
Watch
this is right now you're in saved mode, so you're
Oh.
at 8:27 o'clock
Okay, I'm
instead
sorry.
of
but
whatever time it is.
When you go full screen,
Yeah.
you
Yeah,
can move
so-
it with your finger.
Here's
Oops, excuse me.
Here's a live stream, so you said just move it with your finger. Ooh,
Cool.
That's cool. So you get a better
So
view.
why
of-
didn't we use this to read the humidity and temperature meter?
I don't know.
a sensor
should've.
to read a sensor?
Then we could close the door and we could read it.
and read a full, full closed loop system.
So you actually can do that. We were able to read the sensor if it's facing the right way.
So we
It's
could have
right
verified that he wasn't flicking us.
there.
Okay,
you,
we have
you could go back and look at the saved footage from
Yeah.
that 5 minutes ago.
Actually.
Yeah, there's an idea. Let's go back. Let's
Look
go
at-
back
look at
about
the
5 minutes and let's watch them.
Yeah.
The security
Press the
cam
switch.
footage.
Another thing that's pretty cool, we have a couple different time lapses of the project progressing. It takes a picture every 10 minutes, and this is 11:03, so it goes day by day. Every 10 minutes you can see movement, people working on the house, nighttime. You can see some of the other cameras are set up, they're set up in the middle, so you can see the IR, the lights on them.
How much data was that?
This wasn't very much. This entire video was 274 odd megabytes. So not too huge, not too
That's,
heavyweight.
how many
That
weeks?
this was since 11 till this morning. Or like beginning of the month till this morning.
So the last
28
part of it,
-ish
where you're putting
days.
on the roof, ought to be pretty cool, huh?
Yeah, let's see. We're only at the 13th right now, so we could zoom ahead a little bit. So there's the roof, still working on it, still working on it. So you can see that
Yeah.
piece of insulation up there that we were using to kind of test.
And you can actually see back there that half of the roof is insulated.
Is insulated. Must have been Thanksgiving. Everybody's out. Yeah.
Jumping inside the house.
Yeah, let's see. We'll see that in a second, I think.
Maybe.
No, that's like close to.
A little bit closer to now.
Yeah.
Wow.
And then it's done. So, like, you just program it up, say how long you want your interval to be, 10 minutes,
Okay, and you're
3
including
seconds.
that in your final dipstick
Sure.
documentation.
Yeah, it's just cool.
As well as we have a video of me walking through of
Every single test.
every single test, step by
Okay.
step.
And it's one video or multiple?
One video per test.
Yeah,
Oh, great.
per test.
Yeah.
So you
Okay.
skip the one you want, play it,
Okay.
watch them right down to numbers.
And
So
that,
here's a
that's
question
the test.
I've got for you, Luke. You've done a lot with these cameras. I only want to share one camera.
Yeah.
When I share one, I have 5 cameras at home. When I share one of them, they all are shared.
Okay, are they using, is this other person that you're sharing with using your account at all?
No,
Any of your
no,
login
no.
information?
And I've done it, I've shared one camera like my wife.
Yeah.
She sees all the cameras, including the ones you shared with me.
Wow.
And that
I've
just
had the
doesn't seem
opposite.
like it should work that way.
I agree. I've had exactly the opposite, where you can select what camera you want to share, and only that camera gets shared.
But just by looking at the front plate, it says share at the top right-hand corner.
Let me show you something else.
Are you sharing the camera or are you sharing?
No, I actually put in, so go to the, there you
Kind
go.
of the main area under share, so I've got the shared with myself and
Yeah.
with you, and I can also restrict access to you, cancel the share if I want to.
Yeah, I understand that, but when you shared that one camera with me,
Yeah.
I saw them all. Whatever you have on your account, I see.
No kidding. Okay.
Yeah.
So when I shared these with my personal account, I could only see the cameras I had shared. Have you had a different experience? Have you shared any?
I have shared cameras,
That's wild.
but I haven't, everything that I've shared, has been in the family, so we've shared them all.
Yeah.
Okay. Yeah. So you just obviously share them all.
Well, think of, if you find a way to share only one camera,
I'll play around with it. That's okay. That's how I thought it worked. Because
So
that's
did
how
I.
I've been
I mean,
using it up
that's,
till now.
not so.
It's a huge security issue.
Yeah, that sounds like an enormous security issue for Wise.
Yeah.
So,
Let them know. Get
No,
a
I-
bounty.
I shared
That's
the pond camera
yeah.
with my grandson, and he started talking to me about a living room and I said,
Okay.
no, you can't see those. He said, yeah, I can. And it was these.
That's something else.
So even though I wasn't the owner of these, it still shared them.
I can test this right now if we have something else to talk about in the meantime. Because I've got 2 cell phones running. This is my personal.
Why don't
This
you
is
share
also
one
my
with
other personal.
Share these
Share
cameras
one.
with me. Share the grandma.
Cool.
While he's doing that, that concludes the test plan. All the tests passed within specification. All the functional
So
requirements were
you
met.
have demonstrated every functional requirement and indicated the performance spec, right? There's
You see it.
nothing that has been left out of this demonstration.
Correct. You see it in the test plan that I handed to you, Professor Willie. It has 2 different charts, the one for the order and the passing that we talked about on Monday, and then the test matrix goes through how each test proves one of the functional requirements, or one
What
or
account that you use?
It is Mike.
And I talked to
Start us on.
Dr. Johnson about it, and he said if it had a place where we could get access to it, that he might include it as part of at least a demonstration, if nothing else, for the summer.
Oh, yeah.
activity. Yeah, so
That's cool.
we'll have to see. Okay, we ready?
Yeah, so we're
Okay.
gonna pick up back at the introduction where we left off. So
Okay,
first-
let me say something before you get started.
Okay.
One of the reasons why I like to do the demo first is to have a level of confidence that the prototype works. Okay?
You have that.
With that level of confidence, we will probably go through this presentation then at a higher level, faster speed kind of thing.
Sounds
Okay?
good. Yeah, you've
So-
both seen most of this.
There are only a couple of
Let's go.
So of course, the future needs more scientific engineers. How do we inspire kids? Of course, for researchers, we're included yourself. We're awarded a National Science Foundation grant to promote STEM careers. The teachers come and participate in a 2-week STEM course. Yeah, let's go on. You guys know. So our problem statement, LANA Advanced Systems is creating a scale model home for the purpose of remote outreach and applied research in the field of smart home technology. The model home will function as a tool for educators to use in order to ignite the passions in the hearts of their students in engineering and technology. This will be focused on the fields of additive manufacturing, smart network connectivity, and energy management technology. That's what we just showed you. So of course, this is what IoT is. We have health and wellness, safety and security, energy and cost management. But what we, as a team, have focused more on is home automation and convenience. We also have the safety and security of the door lock, and energy cost management can be added in with our HVAC system. So those are all future additive things.
So the problem statement talked about additive manufacturing. How
Right.
does this support additive manufacturing?
I can take it if you want to. Yeah, so we didn't actually implement any of that in our model.
Okay, fair enough.
But things like all that furniture and stuff like that, it would be an excellent way for a kid to be able to design something, print it off either there or here, and have it added to the house. And I made that, and it's in the LANA house.
Okay.
That would be cool.
Even something like we purchased the port covers. They never came in, but that's something we could have potentially designed and used in 3D printer form.
Okay.
So there's
Fair enough.
tons of uses.
The ability to create an enclosure for the modules would be another important one, which is what they essentially do right now. Is they'll design an enclosure for the launch pad.
Okay.
Okay.
So,
That could totally happen.
Okay.
Yeah.
And
but I was just thinking about, we have a plug-in-the-wall power monitor.
Yeah.
Right.
If we could see that with a camera, so would it be possible to attach, we'll call it a plug strip on the side leg, where we would plug in the monitor, plug in the air conditioning, and be able to watch the amount of power consumed?
Very, very straightforward. 10 minutes to do.
Yeah.
All you need is the module to plug in.
But it would take something like that,
We've got
right?
extra cameras. Yeah, we'd be able to do some research on it for sure. There's got to be, so I know there are modules that are like that, that people have opened up and hacked one way or another and pull the ADC values off as this thing is actually computing what your watts per hour or whatever is, and read that digitally. I don't know if there's something on the market that could do that and then say send it straight to Cayenne. You don't need a camera to watch a little monitor or a plug on the wall, but a camera and a plug on the wall would be super straightforward.
But I can tell the camera to start videotaping, right?
Yeah.
And then download the video.
A lot of times those little power monitors max out at, I think it's 8 or 9 amps a piece, which is right on the edge of what our air conditioner does when it's in full startup mode.
I have one in my office.
Yeah,
If I gave that to you, would you at least try plugging it in, see if it
Sure.
worked?
I'm game.
Okay.
Yeah. Let's do it right after this, so we don't forget about it or something.
so for concept operation, The ETID department will use HANS in the following ways. It'll be used as a teaching tool. It's going to be placed in a controlled environment. It's going to be plugged into a standard wall outlet or several standard wall outlets. It'll be able to be moved around the room. It's going to be a showcase of integration of intelligent devices. It's going to have long-term objective towards adding or upgrading components. We'll be able to utilize both local and cloud services for data, and it's going to be a platform for secondary education.
This is me. So these are the functional requirements that you saw over there that we tested, that we ran through all of them. Yeah, we already ran through all of them. These are the performance specifications that we tested.
We can roll through those.
All of these. Conceptual block
Talk about that.
We've already done the conceptual block diagram.
When you get all the way, stop, go back. Oh, just want to take it. And even down here, you've been able to keep connectivity with Cayenne. It's not been an issue.
4 to 5 bars all the time. We got a heck of a
I
router.
can get that on my phone.
Yeah, it sits up underneath the house, so you can't even see it. It's just
Oh, really?
It was under the house.
Yeah.
And-
It's connected to one of our power boards, so we're giving it 12 volts.
Tell me about how I pay for data.
Ooh, that's an excellent question. So right now we're using prepaid data through NBNO, mobile virtual network operator.
So you
Called
have an
Mint.
account?
We have a prepaid card that's good for 3 months at a time. You stick the SIM in, and it's $20 a month, and you pay upfront. So $60 for the card, and you
And
get
that's
10
unlimited
gig
data?
a month. It's unlimited, but it gets throttled once you hit 10 gigs
Per month.
per month. So we haven't run out. Let's see. So when we were very first started testing, we were using the 2 gig a month because it's a little bit cheaper, it's $15 a month or something. And we ran out at the end of one of our months when we were doing a ton of video work and lots of Cayenne stuff. This month with the 10 gig card in it now, because August through October through November we were using the 2 gig, and we finally ran out a couple days before the end of the month.
Right.
And now that we're using the 3-month card, which should take us through January, I suppose. One of the other teams accidentally connected to our network for a couple days. And
Accidentally?
The TAMU network was down, so being engineers, they looked around and guessed our password.
You're gonna learn on that one, aren't you?
Yeah.
We did learn on that
So
one.
even with that, we're near the end of the month right now, and we haven't hit 10 gig. So
And there's
all
no
the
way
video that we keep doing, and
You say it's gonna be in January. Can I cut it off at 1 December and reactivate it at 1 February?
no, it doesn't work
So
like
it's
that.
a 3-month contiguous
window.
time.
Yeah.
Okay.
From day one of using it and logging in and starting the activating the
And no problem turning it on and off and having it reacquire and,
It's awesome.
Okay.
Yeah, like under a minute.
and again, this is in your bill of materials, right?
Yes.
Okay.
Yes, sir.
Okay, I think I'm good.
This is the overview we saw earlier.
And the size of the complete unit, interface board, everything, is about what? 4 by 5?
4 by 6.
4 by 6?
Yeah.
We talked about this one.
Yeah, this is the mechanical design we went through already.
Right.
So,
That's the location of the air vents.
How do I know that from looking at that illustration? That's what we're.
so
Yeah, that's-
ignoring the walls, I believe.
Oh,
They're
okay.
placed on the floor.
They're on the
Placed
floor.
In the floor.
Yes. So we gotta look through the wall.
Yes.
Yeah.
Yes,
Yeah.
there wasn't any.
Okay. And the carpeting that you put in it?
No
That was
carpeting.
just-
Wood floors, premium.
Wood floors.
That's for my benefit.
All right.
So, and then functional block diagram. Is everything we've seen before. Power comes in through the wall. We've got 3 different voltage regulators. The top one knocks it down to 5 volts. Next one also takes 12 volts in, knocks it down to 5 volts, and then routes out to the 3rd voltage regulator that takes that 5 volts in and knocks out 3.3 volts for our CC3200 and our sensor pack. The hotspot runs off of the 12 volts off one of our boards, and then the PCA 9685, which are PWM controller that we'll see in a second, runs off 5 volts that we regulated down, as well as the USB charging ports. So we've got the Wise Cam connected directly to one of the USB charging ports in every room, not in the basement because there's no camera in the basement, and the cameras that are outside of the house, we actually have 2 of them. We've got a static cam and a movable cam. The static cam is the one that we saw that cool time lapse on, and the movable cam is just recording and live view. So you can see both.
And how many of these fully populated operational units do we have?
We have, so fully operational, we're using Alpha board in the basement because it's plenty for the HVAC. And we have 4 fully populated in the house with the intention of populating the additional 4 before the semester is
So
out.
basement is alpha,
Correct.
and you currently have populated
4,
4
1 for each room.
final,
Finals.
and those are in each room.
Correct. That's what's running right now.
Okay, and what was that last statement?
We have parts and the intention of populating the other 4.
Do you have boards?
I've got 4 extra boards.
Okay.
I've got parts to do them all, assuming I don't have any dud parts or drop anything on the floor,
Okay,
or too many on the floor.
and is there
Fully
anything
populated
that's
floor.
difficult to solder?
The PCA 9685s are the hardest thing, but no, it's just time. So I know it took an afternoon, maybe 7-ish hours to do the middle 4. So the beta board, 4 of them. There's lots of components and.
And
It just
you're going
takes
to
a while.
deliver the additional 4 boards populated.
Yes, yeah, that's my personal intention. Yeah, there's no reason why not.
So we could almost build another house.
That's the intention.
You could almost build another house.
Yeah. Yeah.
You can't find a place to put the one you got.
Go bigger. Build it, they'll come.
Okay? Okay, let's continue.
So yeah, so we have the Wise Cam that's connected. It has a connection 802.11 to the hotspot that we'll see in a second. The PCA 9685 is a 16-channel PWM controller that speaks I2C up to our CC3200.
What, can you inquire what a PWM is set at? Or can you only direct it to have a certain? Can you read over that I2C what each PWM is?
What the
Yeah.
register values are.
So you're wanting to see the,
I just want, if I wanted to know what all of the PWMs were set at, can I do an inquiry?
I haven't played with that much of the library to see if you can extract, I guess, whatever register that's being sent.
Well, you're writing to a set of registers.
Right, yeah.
I guess the question is, can you read from those?
You can read from the PCA 96 register, but I haven't done it. So
We'd have to look further into it.
I would have to look a little bit more into it, but you
we're
should see the. I would assume you can see all the individual.
I don't see why
PWMs
you should there.
Should be able to read from that register.
Can you just scan through the documentation and see if that's possible?
Okay.
Okay, I'm not asking you to do it, I just want to know, can it be done?
Okay.
Yeah. Sorry. And then, yeah, so we have, like Abby said earlier, so 2 PWMs are going through low-side switches up to 4 different ports. So we have examples of what you could plug in. This is an exact representation. So you could actually run 2 servos per RJ12, 6-pin, 6-conductor straight-through cable out to 2 individual servos, which we have like window shades, air plenums, motion sync, door locks. Some of them are dualed up because we don't just have one thing plugged in. We'll have 2 shades, 1 on each channel, and it's pretty straightforward to program. And then on the bottom 4, we have H bridges on each one, the 8870s, and so we have selectable voltage as well that we'll see in a second to each one of those. So 2 voltage lines, 2 grounds, and then 2 PWMs, either the low side switch PWMs or PWM through the H bridge. So it gives you lots of options that you can pull again.
And all of that has been connector using RJ11s?
RJ12, which
12,
is a 6-pin, 6-conductor standard versus RJ11 that's usually 4. But it looks the same as an RJ11. It's fully populated instead of only 4 middle ones, like your phone or your fax might be. Well, we faxes. Yeah, so that's that. We also have an additional 6-pin conductor that connects to our CC3200 intelligence board. It has system-on-chip Wi-Fi. We pass through the I2C line, so the data and the clock. The clock is all downstream, and then we also have a GPIO on the N/OE port, and we give it the PCA9685 5 volts from earlier. We do give the CC3200 VCC, which is 3.3 volts directly through the board, and it works really well for us. We also have a pass-through for our directly to our ADC, and it's actually split down with a resistor pair. So it cuts the voltage in half so it doesn't overwhelm the ADC. And then we also use a GPIO for our motion sensor, and then additional grounds. And then there's our hotspot connecting through Wi-Fi. That can be connected to the board, and then up to Cayenne. Most of our sensors are on the booster pack, sensors pack, so we're using 2 main sensors on that board, so only 2 are listed here. It has additional sensors that we don't use, but we're using the OPT 3001 ambient light sensor and the BME 280 humidity, barometric pressure, and temperature sensor using I2C, so we speak to both of them using the same address.
So if I want to reprogram the 3200,
all you have to do is plug in a USB debug line and fire up your laptop.
but I can't have it powered up.
You can have it powered up. That's exactly how we've been doing it all week.
And it doesn't bother it?
It doesn't bother anything. Based on previous experience with what another capstone team had to go through, we were able to make informed decisions when we were building our board, and build it in such a way that you don't need to move anything. You just plug it right in.
Whether it's powered or unpowered?
Yeah. So it's a nice feature to have and doesn't burn anything up.
Meant to be as easy as possible.
Yeah, exactly. So yeah, we're going to take advantage of their experience and keep going. Then we have a Grove moisture sensor and the Grove PIR passive infrared motion sensor. One of them is just GPIO, high or low, and it's a 3.3 volt logic. And then the other one is an analog value that comes back, so we can cut it in half using a voltage divider. Go to the next one. So a little bit more detail on this screen. Basically, the key part is that all of our unused launch pad I/O, we just crank out to a 40 pin male IDE I/O fan out, just a standard, like what used to be on an old hard drive connector.
And have those signals been verified?
That
It's
they
working?
are continuous. We don't have anything hooked up to them, so.
So the only thing we know is a pin on the 3200 is on a pin on the connector.
Exactly.
Okay.
As well as pass directly through, just as per the launch pad standard, so you can keep stacking stuff
Pass
until you get
continuity
tired. Additionally, we have lots of grounds on that, as well as 12 volts, or 5 volts and 3.3 volts. So if you want to put a long cable on that and start connecting stuff, you probably could. And then we also have, so each one of our outputs. So on the top part is kind of an exploded view of our RJ12 6-conductor 6-pin straight through RJ12 line. The top two conductors are conductor 1 and 2, or V1 and V2, and you can select the voltage that you're sending to those with a little shunt bar. You can select either 12 volts or 5 volts. And then the middle two lines are PWM 1 and 2 that are low side switch to the DMN 2041, and then bottom two are ground. And then on the H bridge, the next 4 ports, you have the selectable voltage again, as well as a 12 volt sourced DRV 8870 H bridge motor driver that you can use. It's an H bridge, so you can use it either way to turn motor back and forth, or in our case, we're using it for dimmable LEDs to turn on or off higher current loads.
And actually, the PWMs are on the bottom side, right? I think the grounds and the PWM should be switched, actually.
You're right.
Yeah.
Yeah,
So just, I guess we can change that.
we'll update that. And then here's a schematic. So power block. We've got a reverse bias FET with a test point. Those are 12 volts into the board. You can go to the next one. And here's one of our main 12 volt to 5.5 volt voltage regulators. Kind of key features are the 0 ohm resistors on the front half, lots of decoupling, a little bit of sense lines. And this is straight out of the data sheet, out of the reference design from TI. It's a TPS 54531 DDA. It's rated for 5 volts and 5 amps. It's got a little indicator LED that's a
How many of
5 volt
those
tolerant.
LEDs have internal resistors?
That one does. Actually, both of them do. They're picked out specifically because they have internal resistors. In an earlier version of the design, we had external resistors, and with lower part count, we went to the one-piece version. So yeah, so both of those do 0 ohms between them, and then we've got a simple 3.3. We take that 5 volts down to 3.3 for our CC3200, and then that goes onto our board. And then there's a second exact copy of the 12 volts to 5.5 volts just below it. Exactly the same design. And then we also have power header expansion pins where it's a 8-pin connector, and one side of it's all either 12 volts or ground, next one's 5 volts or ground, next one's 3.3 volts or ground. So if you want to power something else, which in one of our cases we're powering an Arduino in order to talk to our AC unit.
But those are the same voltages then that are running to your 40-pin connector.
Yes, yeah, exactly. So it's extra expansion pins, so you have that if you need it. next one. Here's all the shunt motor voltage selection. So the middle pin is your V out port that goes out towards your outputs, and then you either are tying that to 12 volts or 5 volts. In either case, all the low side switches are on one of the 5 volt regulators, and all of the H bridges are on the opposite 5 volt regulator.
And we're going to have documentation that shows us how to set up all of this configuration.
Yes.
You're going to describe each one as to what it can do. So you've got voltage selection. That's a whole series of jumpers that I have to put in place.
Right.
So there's going to be something that tells me I have voltage, output voltage selection.
Okay.
And how I do that.
Okay.
Okay. The thing you might want to consider in this, we'll call it board setup, is to do it via video.
Yeah.
I mean, it's quick and easy. You can edit the video quickly. You don't have to worry about all the figure placement and formatting and
Yeah, that
so.
would be a lot easier.
So you have to just talk through it. Everyone goes to YouTube.
Yeah. I mean,
Makes
the
sense.
Wise camera
Yeah.
material is what I'm striving for.
Okay.
Yep.
That seems this way. So that's sheet 1. Keep going. Sheet 2. Here's that PCA 9685. It's our PWM generator. So we can also select the I2C address. 6 bits of it. The 7th bit is fixed. And we're feeding that 5 volts directly from one of our voltage regulators. A little bit of decoupling happening, but not much, because they're super close together. And I2C coming in from our CC3200. Go to the next one. No, you're good. I think it's like a 2-click kind of thing. Here's our 4 H bridges. They're in just kind of standard configuration. An important note is that there's a 0 ohm resistor on the iSense. That's because we want to use all 3.6 amps if we need to on these. If you wanted to in the future, you could replace that 0 ohm resistor with a higher value, and it would lower the output current. So if you needed that feature, all you have to do is change that resistor. But we just populated a 0 ohm for now.
Do those H bridges have shoot-through protection?
That's a good question. I don't remember.
And what? I'm sorry, I wasn't sure.
So
through.
if I were to screw up
Yeah.
on the first one and take PWM 8 and 9 and put them both high, and that I could end up with a situation where through my H bridge I'm shorting VCC to ground,
Exactly.
which would I think be somewhat undesirable.
Exactly.
But I think you have IN1 and IN2. Those are controlling.
Oh, the 2 different outputs, right?
Two different
outputs. But if you were
But
to
you can
put them
still-
both high, you get.
No, you're right, you're right.
Yeah.
Okay.
You're right. Since it is.
That was videotaped, right?
Yes.
That was Professor Willie saying that Dr. Morgan was right for a change.
For
On
the
second thought,
first and
though,
last time in history. Because the career's almost over. He's a short timer.
Well, maybe not, maybe not.
So
My
why
comment
would it
just
have
was-
shoot-through protection?
Well, it has to have shoot-through protection because in that transition, in the transition from on to off,
Okay.
it could potentially short it.
Okay. Okay.
Yeah, I was thinking about a different kind of a part.
Okay.
We're good.
Yeah, go ahead, the next one. Get one more. one of the low side switches, we've got pull-ups on the D1s and D2s, and then those PWMs are coming into the gates. So it makes it active low, so the program is slightly different for the low side switches than it is for the H bridges. This is positive logic, and this is negative.
So we don't have any of these protected with a back EMF diode, right? We're expecting that to be done off the board.
They should be in the next sheet, a little bit closer to the, I believe they are. Well, I think we'll see it in a second.
Yeah, I'll be interested. to
There
see.
are diodes, but I'm not sure if they're in back EMF or
Okay.
not. So there's all 4 of those on the right-hand side. Go to the next sheet. Here's the launch pad headers, and then on the right-hand side is the fan out for all the unused CC3200 launch pad ports that we aren't using, as well as a couple 12 volts, 5 volts, 3.3 volts, and tons of grounds. So we have lots of options, as well as these CC3200 pin headers are male and female, so you can just stack a board on top of or below. Our board doesn't really care, just as long as it's pointed in the correct direction. And on our PCB, we've got pin 1 clearly labeled so that you point it in the correct direction. So that these all actually fit. We can go to the next one. Here's our dual USB charging ports with the PPTC fuses. So they'll go up to 1 amp safely, and it's just a simple.
On those fuses,
Huh?
how long does it take at 1 amp to have them break?
You have to look at the spec.
Yeah.
It was
They're supposed to be rated at operating temperature. If it's a 1 amp fuse, that at 1 amp it should go infinite.
But how long does that take?
It was milliseconds on the stuff I
Really?
was looking at. It was very
And then
short.
what's the reset time?
Again, you have to look at the
Yeah,
specs.
but
Yeah.
typically is it, I would think it'd have to cool down.
Whenever
It
cools
does,
down,
but they
yeah.
cool pretty quick.
Hello, come on in.
Oh, hello.
How are you? Told me we were doing a review, so. Hello, guys.
Howdy. Welcome.
Figured they could get some experience in.
Okay, cool.
So this is LANA. They are creating an IoT house for us.
Oh, okay.
Sitting out there. And they've already done a successful demonstration, so now they're going through their complete design presentation.
Oh, okay.
And you're about 3/4 of the way into the schematic.
Right. Yep, so we'll just go to the next one. These are 2 USB charging ports that we're using to power some cameras on our design. So we go to the next component. So here are, let's see, I guess those aren't really in back EMF. Well, they could be. So here's our ADC and GPIO from our water and our motion sensor. On pin 6, you've got our motion sensor, which it just uses a simple high and low, digital high and low. And then on channel 5, you can see the voltage divider. Because the voltage coming back from our water level sensor is basically double what we needed, so we just cut it right in half so that the ADC that doesn't have quite the 3.3 volt range, it's more like 1.6, 1.8, can handle the values that it's seeing. So we can actually measure the depth of the water if we need to, as well as 3.3 volts with ESD protection, I guess, going out through a RJ12 6.
So this has nothing to do with the low side switch.
No.
And there was no requirement to be able to do that. We just have to remember, if we are going to control some kind of inductive load, that
gotta
we're
be
going to
out
have
there.
to put protection diodes. And they should be, my understanding, as close to the load as possible.
That's usually the best.
As close to the load as possible, so shorting out or not shorting out, but bridging the 2 connectors on a
So
motor.
we'll put them at the device
Yeah.
side.
Makes sense. Okay.
But if you would put a note in the technical documentations on especially the low side switches. I don't know whether the H bridges are protected internally or not, but I doubt it. That for inductive loads, a back EMF diode should be used. We're just having a difficult time convincing NASA where it should be. They want us to do it, we want them to do it, so.
Cool. Sounds
Okay.
good. All right, we can go to the next one. So that's that. Let's see, here's the 4 low side switch control modules with the different selectable voltages, either 12 volts or 5 volts on pins 1 and 2. 3 and 4 have ground, and then 5 and 6 are low side channel 0, 1, 2, 3, 4, 5, 6, and 7.
And all of these are at 60 hertz?
All of them are 60 hertz. So that's all those, and then the next one should be the 4 high current control modules. The high current being limited to 3.6 amps, or limited by the power supply and voltage regulators that we're using. So the same idea, where we have the selectable voltage on 1 and 2, grounds on 3 and 4, and then H-bridge 0 TV layout. There's a little scale in the corner, but
I
it's,
have to reset the camera before that.
Oh,
it has a max video length.
Sorry, guys, yeah.
You're
Oh,
okay.
you're fine.
So it's 6 inches wide by 4 inches the opposite direction. It's set up with the 40-pin IDE fan out all the way to the left underneath the board, as well as a PCA9685 PWM generator, also on the back side of the board. And then you can see kind of on the left-hand side, actually if you pull once or twice, you can see DC in, coming in from our wall jack with nice big connection planes, dual USB power out, the CC3200 launchpad interface that's above and below the board, so you can stack as many as you like.
and how do you have them stacked right now?
We have it stacked, so if you kind of look through the board to where all the blue layers are, that's the back of the board, and that's where all of our voltage regulators are. So they're producing the most amount of heat, so we put them underneath the board, as far away from the temperature sensor, which sits on top of the board.
But
So we
how
have
do
a
you have
physical
the stack?
distance.
Is it your board?
Then a CC3200, and
And
then
then,
temperature sensors
okay.
and pressure and barometric pressure and
Okay.
humidity and everything else,
Okay.
as far into the air. Of
So
the
where
walls.
are those, I guess they're wired in, the moisture sensor and the
Yeah.
They're connected.
PIR sensor?
They're connected on the other side of the board at the top with an RJ12 port.
Okay.
Yeah,
So
so
they have their own
actually,
special.
Okay,
right up here, yeah, this guy is the sensor port,
okay,
and then here's 4 low side switches, or dual low side switches actually, and then here's port 1, 2, 3, 4. Those are all low side switch with the selectable 12 volt or 5 volt DC with just a little shunt bar.
Mhm.
And then here's all of our voltage outputs. So one stripe is ground, next one's 3.3 volts, next one's ground, one's 12 volts.
So we don't want to put any jumpers across those?
I hope not. Yeah.
I hope your video tells us not to do
Right,
that.
yeah. It would be disastrous. Could be disastrous.
Okay.
Then here's our H bridges, so 1, 2, 3, 4 of them, and then our 4 higher current modules are on the right hand side.
Okay.
Oh, yeah, there it is.
And that's a right angle 40-pin connector, right?
It is not a right angle. It's straight up because a
Can
lot
I
of.
get to it?
Yes, very easily.
So the 3200 isn't covering it up?
Not at all. We double checked that.
And it's on the top rather than the bottom?
It's on the bottom.
It's on,
So it's on the bottom, and then a lot of the ID connectors, the connector itself is right angle. So it's kind of a crimp connection on a big flat ribbon cable, and you crimp it down, and the ribbon cable is sticking out anyways. So we thought that was pretty good. And then triple voltage regulators. So the big pores are 5 volt regulators, and then the little one that's kind of hidden behind the H bridges is our 3.3 3. Go to the next slide. Here's a colored view of the same thing. And just seeing some of the footprint sizes. PCA 9685 are 16-channel PWM generators up on the right-hand side. And just some of the routing and things like that. Actually, if you go back, something that we implemented in our design from one of the big changes that wasn't hardware related, but just user interface related, was adding a lot to the silk screen. So up over here, this is where you can select the I2C address with little shunt bars. And we even put on here, here's the I2C address, select for the PWM driver, all open, your address is 0B40, 1 and 2 are shorted, 0H40, 1 and 2 are shorted, it's 0H41. So just so you can use it, and definitely in testing, it's been very helpful to say, okay, that's the 12 volt or the 5 volt, because you don't want to blow up your servo motor by accidentally giving it 12 volts. That's bad. And then,
not ideal.
Not ideal, yeah. And then if you go to the next one, something that was also like super helpful was putting down what port number it actually is, what PWM number it is when you're programming it with the PCA 9685 and EA or in C, so that you can say, hey, this is the line that I want. I want pin 6 to be driven high or low or whatever the case may be. It's exactly how you can program it. So just, it's been super helpful, and I wish we'd done it in alpha, because when we have to work with the alpha, we go back to working with the alpha board, it's a little harder to do.
I think we saw some demos of that problem, right?
In the first alpha?
Yeah.
Okay.
Just user interaction, it's a big deal. Much better. So we can go on.
Click one more time.
Out in the software.
So just, what I wanted to go over was the kind of dashboard layout, so we did go in depth in that demo. The servo control, because it's kind of mostly what we're doing with our low side switches. And then I wanted to show the monitor temperature, and then the publishing data to Cayenne and kind of how that's operating. So here's our dashboard. You're going to get all your rooms and your HVAC tabs there. You just click it and it pops up your new window. And you can see, as we saw in our demonstration, the indicators for cold and hot, if your air vent's open, water leakage, motion detection, and then all your sensors, and then your window capabilities, adjusting its visibility through the door, the window, and then your door locks and your motion simulator.
So we have a project at a high school. We would send them this.
So this account is just under our email account. So it's LANAadvancedsystems@gmail.com, and then our simple password, and you can share that with anyone as we've.
So they would just log into this account.
They would just have to type in those credentials.
Okay.
Teacher
So
or
what if you're doing it at 2 high schools at once?
We didn't have management for, like within Cayenne, so it would have to be a administrative kind of, I guess, timely, however they would keep logged in.
But now I know how to log in. I would leave these entirely alone. If I wanted to build my own monitoring and control module, I would add a new, I forget what they call them over there.
The widget or
Little tabs.
Yeah.
So, okay, so you're saying, say that one more time?
I'm going to be monitoring light in the room,
Okay.
okay, and adjusting the blinds and the LEDs. I would add that as another element on the left and build my own dashboard
Okay.
that could access the same sensors, right?
So you cannot add, so each of those is one device only. So room 1 is room 1 CC3200, but you cannot add another tab that accesses that same CC3200.
So I'd have to rip this apart.
If you wanted to kind of, well, you don't have to rip it apart. So what you do is take out the widgets that are here and add new ones to.
That's what I mean.
Yeah.
I'm going, so is there, how do I maintain this?
Super easy. Okay. It's just like, just the add new green button. I mean, I did it on the fly, like just while we were setting things up. But essentially, every single one of these, you can just remove by simply clicking the settings.
But I don't want, I want to be able to get back to this
Like a safe.
fundamental level,
Could you
the
save
default.
this as like a default
Okay.
dashboard and then?
But if I go in here and start messing around,
I see what you're saying.
then it's gone.
Yeah.
Oh, okay. So I think what you would have to do is, so here I'm only in one project. So I think that's what you mean. So maybe you
We could add a
another
project
project.
and bring these in.
Right. So you would have to add another project, put in the same devices.
Yeah.
And then you can
Then
go
we
ahead
could-
and change the other windows and say you wanted to keep these without, and just having its basic functionality.
Separate project.
Yes, I see what you're saying now.
And so we could give 4 different schools a room.
I want to double check that.
They could add a project and be able to
Play with their
control
own.
that room.
Right.
Okay, I need you to verify.
I want
that,
to. I
so-
want to double check the. I'll just add a new project, and then
Yeah.
I'll see how it affects the previous one, because I feel that it'll just listen to the other project devices, but I'll definitely get back to you on that.
Yeah, so we have our default
Right.
project,
Okay. Yes, I see where you're going.
okay?
with
And then I want a room 1 control project.
Yeah, that's a really good question that we definitely need to test,
Yeah.
because we've had some issues where it'll ignore one user if 2 people are logged into the same account or 3 people are logged into the same account, all messing with stuff at the same time. Sometimes it'll ignore you. So, yeah, with
That's-
different
that's-
projects,
we'll
we'll
double
double check.
What would be involved, so right now we've got this common Cayenne account, but let's say that
You want to
North
set your
Garland High School wanted to do this, and they didn't want to use this particular, they wanted to have their own Cayenne dashboard, their own Cayenne account. What is the process to take the devices and have them report to a different Cayenne account?
So actually, that seems like it has to be programmed on the Launchpad
No, I get that,
It's pretty involved.
with a different ID. Yeah.
but is that very involved? Is that something that you have to do
Not at all.
7 different places, or is it some place where you go into a header file, you change it once, and recompile?
For each
Exactly.
Right.
control.
Once per
It's
each
just
room.
yeah.
Okay, so you do it once,
Change
you
it once.
recompile it, and then reflash each of the individual
Correct.
controllers.
Correct.
And then build a dashboard from scratch.
Okay.
But if this project will let us,
Do it at
Do
the
it.
same time while you're having the other ones on the same device. Yeah, that'll be.
that would be wonderful. And this is the kind of thing that you're going to need to make sure Michael understands
Okay.
on how he would go about doing something in the future. Okay.
And I think this is another area where instead of written documentation on how to do it, where video documentation showing what you click and walking through would be dandy.
And I use Debut,
Is that
Which
like
is-
recording your screen?
recording your screen and your voice.
Okay.
Okay, so you set up a remote mic and it's just a lot smoother, a
Okay.
lot easier. You can edit it. You can add videos, you can do all sorts of things with it. But yeah, we need to have that capability, and that would be perfect if it works. So, no pressure at all, but
Yeah, it was kind of,
just send me a thumbs up picture
Actually, now thinking about it, even if you started a new project and you're adding a new device, it'll give a different ID for that device. So already, just by adding another project and adding more devices, you're gonna have.
I don't want to add more devices, I want to
You want the
reuse
same
these.
ones.
I just want to use a different dashboard
I'll
and
see,
control.
because they're fixed once you add a new device, which is that tab there.
Yeah.
It'll give you a new
Take a look.
ID.
I can't believe that he doesn't allow that
I'll
to
look at it.
happen.
Yeah, I'll look at it. Okay.
We need that.
Okay, yeah.
And
That would be good.
we can get it next semester. No pressure.
So this is your, if you go to the next one, it's just showing you the HVAC and then the ones that we saw. And then it's good that it'll, if you go back, it'll show you if your power's on, if your HVAC is on or not, from Cayenne. So that's a great feature. So right now we're going to servo control. If you just keep pressing, this is how we're controlling it. Just wanted to give you an example. Here's the slider min and max from 0 to 100. Here are its ranges, and we do a little math, getting the range of this bit and finding a multiplier that is that multiplies with the 0 to 100, and then finally we get the specific rotate position for our window blinds, and that's kind of a nice way to show that show the kind of the math related function that's being
Okay,
used.
and the window blinds are your creation, right?
Yeah. They were based on David's
Yeah.
design, kind of using the same idea as his, but with a different approach.
And do we have documentation on how you did that?
We have pictures so far and written documentation to follow.
Okay, because I think that will become a potential basis for a high school project to either replicate or to
Oh, yeah.
use it as a base to do other things.
Yeah. Even to bench test them, it's cool to see.
Okay.
Rotate a servo and your blinds change position.
I mean, that's something they could do out there to get an appreciation of what is happening in here.
You're right. You're right.
They could set up their own little, okay?
8 lines on
7 windows?
Seven.
7 windows, yeah.
Well, they only need to do one,
Yeah.
but they get an idea, that's a project they can do.
Come to A&M.
Yeah. Okay,
So now the monitoring temperature, and this is kind of what I wanted to get at. So here, if we're within 2 degrees, we turn off the hot and cold indicators and we store this data. We don't send it yet, and I'm going to explain this in the next slide. And then simply if we're below 2 degrees, we turn on the cold indicator, close the air vent, and then turn off the hot indicator. And then the exact opposite is done if we're above 2 degrees of our user set point. And that gets stored.
if the room temperature is 2 degrees above user temperature,
Yes.
that means it's too hot.
Too hot. So we turn on the hot indicator, correct? And then we
Okay,
turn off the cold indicator
yeah,
and we open the air vent because
Okay.
it needs.
okay, got it.
Wait a minute though. So this only this logic is true for AC, but not for heating.
Right.
So,
Okay. Okay.
But I mean, if you heat it, right? So you'll still.
Now, if you
So
heat it,
what-
the vent action is opposite.
Oh
so
yes.
what
Yes.
I would
Yes.
hope.
That's what we were.
We
So-
didn't check that in the,
we actually did in a way. So
Yeah.
the,
I remember that.
Now,
this is called a tap dance.
So, are you ready for this? It's actually all in here. So there's a manual switch for the vent that you can hit, and it's actually on the first dashboard.
I don't think I updated it to it. So
Okay,
it was.
so it's
it was
right
here.
there in the bottom right. I can pull up the kind dashboard now if you'd like.
No, that's okay.
There's a manual switch. So I ran into this problem in testing. There's a manual switch, so you can You manually turn on the HVAC heat, and then you manually open the vent, and the manual overrides that logic
Correct.
of the 2 degrees over.
So when you are heating, you are not exercising vent control. Is that
You
what you're
are
talking?
exercising manual vent control.
Right.
Yeah.
That's a
So
good point.
I was able to get it from 67 to 77 in about 6 minutes, but you have.
So
you have
I get that, but that means that when we're heating, I can't maintain 2 different rooms at different temperatures.
You can.
No,
So
Each vent
control
control is,
I have to go in and manually control each vent
Right.
Right.
rather than
Yes.
thermostatically controlling the vents.
Exactly.
Correct.
yes.
More dynamic.
So how was that set out in the
Functional requirement.
in the functional requirements?
It was based
Did we
off
say that-
cooling.
So the functional requirement, the exact wording of it is that we have control of the indoor temperature 5 degrees plus or minus 72 degrees Fahrenheit.
That we can control.
That we can control. It didn't say whether or not it was controlled thermostatically, manually. The functional requirement is
What
that
functional requirement relates to the air vent control? Or the air vent, is air vent control even mentioned in the functional requirements?
it's not specifically outlined as a functional requirement.
The customer needed to hire an attorney.
Yeah, it's,
So let's just get to the bottom line. Is it possible to add
yes.
heating to this?
Yeah, so we talked about this yesterday, and the way I think we thought to do it would be, you would have 2 sets of logic for heating and cooling.
So what Jacob had said, if our sort of like desired temperature went above like the previous desired one, or like, how was it?
So you would do it based off of your set point. So if your set point was at 77, it would know that you were trying to heat.
So there's nothing that prevents that from
Right,
being,
from
so
being implemented.
that could potentially be a student project.
Whose side are you on?
Students.
Students. Progress.
A really simple way you could do it is just
Yeah.
to alternate between, are you want to use the AC or do you want to use the heating? And you
Yeah.
manually choose that,
Mhm.
and then there's just 2 separate logics that takes that radius right there and just switches the
One that
vent
ignores the
direction.
AC one and then just goes for the heating one.
Just changes the
something
vent
that's
direction. Because that logic
relatively-
still works. With the
Relatively
vents.
easy to implement.
You just have to manually select AC or heating. That's a very cut dry,
You
really
just said it was
simple.
easy.
Yeah.
Oh, somebody who
I-
So you've
I
been
said-
trained, I've been listening to you.
Yeah, I've been.
He didn't
Okay,
get
if I
finish
could
the training
rephrase,
course.
it's rather straightforward to implement.
Too late. The 4-letter word is out.
So I'm trying to think about my thermostat. I think my old one, I actually had to tell it whether I wanted to heat or cool.
Yeah, that's how my house is.
Some mine is as well.
Regular
Yeah.
house.
Most homes.
But I think mine now does both. It looks at this 2 degree, and if I drop below the set temperature, it'll turn on heating. And
So you got the high dollar one, because that's generally commercial, that does the automatic.
And in fact, it allows me to set 2 ranges, heating and cooling.
Right.
Yeah.
Okay, I will buy into this idea of you choose whether you want heating or cooling.
Cooling. It's a really
And
good
then
thing, yeah.
control it that way. However, that's done on a room by room basis.
Room by room basis.
So how are you going to do that if you only have one atmosphere?
Energy source or,
Yeah.
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 So you can only heat or cool.
Only heat or cool, yeah.
And that's a common problem with all, with all duct controlled
Yeah.
thermostat systems.
Well, I've got a split system, so I can
So-
do all sorts of.
So we need to tell them to put in another air
I think
conditioner.
I put heating and air conditioning.
Zone
Oh,
it,
heating and cooling, that's
yeah,
interesting.
so that we can zone it.
Too much information. Our air conditioner is a heater air conditioner, but it's really a air conditioner. And depending on which way it's running, forward or reverse,
You either
you're
pump the heat.
either pumping cold air out or pumping heat out.
Yeah, it's a heat pump.
So just a heat
Yeah.
pump. So if somebody wants to harness that output, you can have heating and cooling
But this, no matter how,
at the same time.
For future,
Well, actually, they do, actually, in big industrial, they do.
Yeah, yeah, and then, yeah, because you'd have to set up a second,
A whole second, like parallel system.
That's
and
the
a
way all
separate
of
dump
these are.
system, yeah.
Yeah.
Yeah, they might as well take advantage of it.
And hold air to this room, and
Yeah.
the thermostat decides which.
That's good. That's good.
Yeah.
I think.
So I think we ought to have that
all
operational by next week.
Still creepy.
I don't see how. This runs air conditioning, right?
Right.
Which I think
Towards air
is
conditioning
is
in
what we
Texas.
want.
Okay, so we're happy with this.
And we've tested this, right?
Yeah.
I
We
think
watched,
I'll
yeah, we watched that.
take this and understand
When
that
you-
your grade just got lowered.
You watch this, have the ability to control the temperature to 77 degrees and 67 degrees.
Okay, so now this is publishing the Cayenne, so if you just click once, we're gonna go through the checking the reading temperature, reading pressure, reading motion, monitoring moisture, monitoring temperature, and monitoring motion, and that's just reading the sensor data, the sensors from the PIR and the moisture water level. So what that does is it reads it every 2 seconds and it puts it in our little storage, and if you click it one more, the way it works is we have all the indicators that are on the dashboard listed, and each of them has its own structure. It's a structured variable, and it holds its channel, its data, a sensor type, and its unit. And these two are necessary strings that go in formatting your Pascal and whatnot. So every single one of these.
So you're using the Cayenne structure rather than the, whatever they call it, default or open, or where you can put anything.
The MQTT protocol.
Yes, so that's the way I submit data, but if you click it one more time, so that was just indicating all the channels, but click it once more, and then again. Okay, so now going through the actual publishing portion, what we do is we publish the first set, and as you see here, it sends the motion status is separate from the next set of information, which is these other, see the cold indicator, the hot indicator, and that's when it updates this portion and updates this portion. So instead of simply just write, this is the only time that I write, but here I update its individual struct values. So the point is that every time we're constantly updating its individual library per se, and then we steal from that and publish what was just recently read. Was there any, I think you needed to.
Oh, that's the flaw. Now I'm wondering if you really can fix the flaw in the motion sensor.
Well, see, in this case, I have send desired temperature and send desired temperature in both sides, in both sets. And also, this is 5 seconds, which I could easily reduce to 2 seconds.
Without overloading Cayenne.
Without overloading Cayenne, this was my safety number because I just wanted it to work the first time around. But the limit is 10 write statements per second. So this is like double or the timing that we're waiting.
Okay, so now let me ask you about the motion sensor. So the motion sensor, you're getting a digital signal on the motion sensor, is that correct?
And I think I didn't double check the setting that it was on because there's 2 settings. One is continuous trigger and one is kind of pulsing. So if it was just pulsing, basically we were kind of every 2 seconds kind of seeing, it could have been higher or low. But if it was continuous, we would have read it, and it pulses high for 3 seconds. So I feel that if we just reduce the time that we're waiting for each set, and also maybe just add the same motion to this next one, it'll be there as far as that goes.
I mean, I have a question for you. Do you really need to update the temperature every 2 seconds? Are you gonna see this much change in temperature over 2 seconds?
So especially if you're, like how we were doing today, we were just kind of wanting to get it to different values to see that it was testing. If you were in a regular home, you probably are not moving it that much, but for our purposes for today, yeah, we did do it in both, but
So I think for testing purposes, it was helpful to have it updated that
But
frequently.
we're gonna be
Are you
testing.
guys using a single sensor in the entire room?
Yes.
yes.
Oh, so you're not using a mesh network of sensors, for example, distributed around the room?
There's a sensor in each of 4 rooms.
That's fine, but if the room large enough, then you're gonna see quite a bit of fluctuation in different corners of that room. So it would have been wise to have a wireless kind of network that's being set up, basically a bunch of sensors around, for example.
Well, I don't have that, so. My sensor.
For example, for
In fact, my
in a
sensor's
big
the
hall,
hallway.
in a big hall, for example, you can do something like that.
Sure.
So our device is going to be used for students like in a classroom setting, which they don't have, 2 hours to wait for the temperature to change. So like we are with testing, it's going to be the same environment. So it is valuable.
I understand, I mean,
Yeah.
the idea behind the testing purposes, yes, absolutely.
So do we have a fix for the missing this?
Yep, I could just reduce the time and then add the motion status to also the second set, so.
And that should take care of missing like we
Missing
saw.
Yes.
Okay.
So you're going to implement that and test it?
Yep.
And
Probably just
validate
right
that?
after this. Yeah. Yes.
There are going to be a series of action tasks that come from this review that you're going to take care of and report on in an email to the stakeholders. Okay.
And then lastly, we get interrupted every time we receive a command from Cayenne to change the servos or the lights, and that simply updates the actual servo, and then updates our data that we use to send, and that's kind of how that operates.
Okay. And we've already seen the testing, right?
Yeah, so this
Is
is
there
the test
anything major
matrix.
that you want to tell us that you didn't show us out there?
No, we already walked through it all. This
Yeah.
is the flow diagram. This is exactly how we went through it today.
See how trusting we are
Test
now
plan.
that you actually did it?
So, yeah, sorry. Yeah, the test plan is pretty detailed, it's 18 pages.
And you're
We
creating
walked through
a
that.
report
I'm
from
creating
that
a report.
testing you did.
Yes.
And I'd say it's a separate document.
The test report.
Yeah.
So we were,
Let's make
I
the
was,
test report a separate document.
then I was planning on including the results,
Oh,
kind of a
absolutely.
summary of that in the documentation.
Yes.
So the test report will be a separate document, and it'll include all of these
Yep.
written.
Yep. Those
Test
can
results.
be scanned in or whatever you want, but, okay.
Okay. And that's testing, because we pretty much did all of it already up to this point.
All right.
This is where we would have pause for the demonstration.
Yeah, here's our schedule overview. Everything's green up until today. We're still working on our final test report, final documentation. We're pulling that all together, including the 2 flash drives, one for stakeholders and one for Roseanne, of the whole project notebook and all of our design.
And any additional items that we have identified in this meeting?
Of course, yeah. Yes.
You've got this under your email address?
The LANA, no, it's under
It's-
the dashboard?
Yeah.
No,
We
it's
set
under
up under LANA Advanced Systems at gmail.com. Everything is owned by that email address.
Okay, and there's no reason that that should ever leave, right?
No, it should be good as long as
No,
Google's
yeah, this is
around.
There are
like-
2 things that need to happen.
Yeah, it's,
Number one, obviously, they need to
Handoff.
pass you the appropriate credentials.
Yeah.
right.
And number 2, you need to log in and set the alternate credentials in case something ever happens that you need to reset or recover a password. So in Google, in any Gmail account,
Oh,
there
yeah,
are
I know what
alternate
you're talking about. I
credentials.
thought you were talking about in Cayenne.
No,
Remember that happened?
That's a good
No,
idea.
I haven't.
No, you need to do both.
Okay.
Because the secondary email is one of ours.
Okay.
Yeah.
I would assume.
I think
The recovery.
Yeah, and I would suggest doing that while you have access to them, because I do not recall if Google tries to send to that secondary or use the phone number associated
Yeah.
with it if the secondary email doesn't
Oh,
work.
if you're trying to change?
Yeah,
Okay.
that may be a security issue that you need to take care of while they're
Two-factor kind of idea.
available.
So let me have those and I'll try to do that this evening.
Okay.
So what do we got left here?
Just project management kind of stuff.
Something I want to point out is we have project closeout is December 5th. On the Gantt chart, it's slightly different.
Okay.
That was not good.
So you have done your final demonstration. You are working on your final presentation. You essentially have three major things left. Your final documentation, your final test report, and closeout. Is that right?
Yes, sir.
And you're going to have all of that done by December 5th.
I think that was.
Yeah.
We were
Is that right?
We would like to have it done by the 5th, but I think if we look at the next slide, it's the 7th that we actually were shooting for.
The deadline.
Yeah.
So Professor Willie is going to have everything he needs to assign you a grade by December
December 7th.
7th.
Which I think is Thursday. It's Friday.
Oh, and the paper.
And the paper, yes. That'll be in your hands later today.
Okay, I gave you something.
You did, yes.
Okay,
And I've been working on it past 2 days. I wasn't able to work on it too much yesterday.
But it's got to be in.
By Friday.
This-
By the 1st, which is either Friday or
The abstract has to be in by the 1st.
both of them do.
Both of them do now?
Yeah, we identified that both of them do, just a little bit
Well,
ago.
generally, the abstract's the first part of the paper.
It is.
Okay.
It is, yeah.
And
So-
that's due by Friday?
Yep, only thing I need to do are add figures to it and slightly tweak some of the stuff so that it fits their rubric.
Okay, but I gave you a couple of suggestions on that. Acronym,
Acronym.
presentation, and
Yeah. yes.
something else.
Yes.
Okay.
Yeah, so it's very close. It's very close.
So I'm going to get that today.
Yes. Yeah.
Okay.
I'll definitely say today.
And you've got the list of authors, correct?
Yes, I've got a list of authors.
Has
Maybe-
Dr. Porter provided any input?
He hasn't.
Okay, so he's not.
Yep.
Going to
May
be
I
on.
use your author bio from one of
Oh,
your other
absolutely.
papers? It seems pretty standard.
It's, yeah, okay. Who
Is it?
cares?
Okay.
But you guys had to put bios in, didn't you, or some
Yes,
descriptions?
we do. Yeah.
Okay.
So that's part of the work that's still remaining as part of the, I'm shooting it to you and then working on bios.
And
Some short bio.
you're going, at least some of you are going to make a presentation of this paper.
We will, yes.
So be thinking about, one thing I was thinking about was a short clip of the building
Right. I agree.
of the unit. Might be interesting while you're talking about something.
That's the window blinds. The next test we're going to do is the heat lamp that simulates like warmth from the sun. So Luke, if you could go ahead and fire up the IR sensor, the IR camera.
Oh, yeah,
On
yeah.
there.
Sorry. Yeah. It's like the IR sensor.
Yeah, sorry.
You're right.
And we are on the insulated or non-insulated side?
Non-insulated.
Non-insulated?
Yes.
How is it you know that?
You can see it.
So it's non-insulated on the front door.
Right now, you can always rotate it.
You could turn.
You could turn the roof. We have 4 different zones.
The roof lifts up and spins however you like it.
You were waiting for that question.
Yeah.
I knew it when she came in, but I could try.
Alright, so here's a demo of the IR camera. Right now it's a live view facing this way, so you can see yourself, see where the hot zones are. I only shared one with you.
Okay.
All right. It says waiting to accept, so you can go to your notification.
That was 3 points.
No, hey.
We'll pull that up for everybody to look at here in a moment. Let's go to the Wise Cam first. Okay, accept.
What was that?
So wake up for
Okay,
demo.
I got LANA living room.
That's the only one I shared with you. You should move around and do all the stuff.
But you don't have any others?
Not right now.
I only shared one.
That's strange.
Yeah.
It's odd that it worked like that.
Like I said, I couldn't believe it.
Yeah.
And it wasn't my cameras. Well, it shared it shared everything, including
Yeah.
the house.
What had been shared with you?
Yeah, everything that I have, that I can see on my account, got shared.
We're using an Apple device or an Android device?
Android.
Okay. That's all I've ever used.
So you're showing
Yeah, this works.
only one camera.
Just one.
Well, let me,
Hopefully
I
it's
got
just
that
one.
camera, that's it.
All your other stuff.
And I'll play around with mine then and see why.
Maybe there's a button or that's like a share all though. I don't think you would have pressed it. Like you would have read it and not pressed it. That's weird.
But when you share a movable camera, the person that gets it can also move it, right?
But they can't.
But they can't
view
change.
They can't change settings and they can't view playback. The recorded stuff.
Oh,
They
really?
can only see live.
Okay.
Because who knows? If I share it with you today, I don't want you to see what I was doing yesterday.
Why?
I slept in the house.
Okay.
We took the switch from the wall, put it on.
That's the gosh.
Yeah. Looks just like it, right?
Yeah. Fortunately not.
Okay, so quick break for coffee and then
Yeah.
we start the presentation.
Let's do it.
Channel A is on 5, H bridge number 0, channel B is on 6, so that way you can have full control of the motor. And those have a 12 volt input and they use a little bit internally, and we were seeing at full 100% duty cycle right around 10.7 or so volts
At the load?
at the load. So there's a little bit of a drop across that H bridge for one reason or another.
Really?
Yeah.
How much current were you pulling?
That was, let's see, that was with a little LED strip, so not much. Probably, if I had to guesstimate, 200 milliamps-ish.
And you sure you were getting 12 volts unloaded at that output?
Yeah, it's routed directly across the board from our 12 volt.
Yeah, but when did you measure it at that connector when it was unloaded?
Yes.
And it's 12 volts?
Yeah, during testing.
Is your motor is rated for this much current? Or you want more?
No, so that was kind of an extra step that it's designed for a unknown use case where anything that we're driving currently today in our demos is with those LED strips was about 350 milliamps.
What's the per pin current rating on an RJ12?
Per pin is 1.5 amps with a max peak of 3 amps.
Okay, so we're well within the current rating
Yeah.
at 200 milliamps. Well,
And what was the connector to the load wiring?
Let's see, it was, that's a good point, because it would have been our standard RJ12 jack, and then we're using Cat5 cable, and then we were using just those little, because it was only in testing, we were just using those little GPIO
little short wires with a male and female on either end.
You mean jump wires?
Like jumper wires, yeah.
But a volt and a half is a lot of drop.
Yeah, well, it was yeah.
And you've
It's like
seen that
1.3
on all of them?
Only on the board that we tested. Yeah.
Oh,
That
the
would have been,
first room.
that was on, yeah. So, only on one board that we tested, and
Was that alpha?
that was, yeah, we saw it on Alpha, because it was on that day that we had that demo.
Okay.
Have you
Because we
looked
were-
at any of your final boards, and
Not with a load, not like that.
why don't we just check that to
Let's
see
do it,
if you're
yeah.
still seeing it on final?
Okay. You go to the next one. So that was the end of page 3. Yep.
Yeah, so think about pictures you want to take. You got a picture of the team, you got a picture of the team with the house, that kind of thing. And get good pictures of inside the house so that you have those if you need to use them, not necessarily in the paper, but in your presentation. And that all happens like in March?
Yeah, identified the date, it was right, I remember it was right around St. Patrick's Day for
Yeah.
me. But yeah,
Okay.
it's right around mid.
So anything else? The
let's
4
see.
boards,
Before boards.
no, the 4
The
additional
4
boards.
boards, exactly. Let's see, so action items were guarantee motion detection. We're gonna look into power monitoring just after this that you've got. We're gonna look into how possible it would be to read, say, register values from PC 9685. We plan on doing output voltage selection videos and kind of like a how-to series for how to actually operate these boards. There needs to be a note on the low side switches about for inductive load, back EMF is needed. Let's see, need to do a final power check on the 12 volt H bridges for voltage drop issues on our beta board. Look into adding new projects in Cayenne.
Yeah, that's big.
Credentials and alternate credentials for
Yep.
Google, that has 2 stars. December 7th. And then for today, finish the ASWE paper and send it to you. And then photos for, I'm going to say, media plus presentation.
Yeah, that
As
is,
well
I
as
thought
an
about that, but
email
there
with all
could be
this.
an opportunity to do, at minimum, a joint departmental, ours and the College of Education.
Oh, yeah.
Yeah, so I don't know if you can get Michael over here
Michael. Yeah, right. He's
to,
last time I checked, he wasn't, but
well,
I know he's forever.
definitely get him with just you guys, but if Michael could join you for a photo op, let's do that.
Yeah.
Okay.
Go ahead. All these sound pretty.
Yeah, here we go.
Yeah, so original SDP labor estimate was 1488 hours. So far we spent in only capstone 2, 1,362 hours and .38. And it, as far as our RAM goes, it looks like we're about 54 hours away. That doesn't include some of these items, so
I'd say that's
in that range probably.
Does include documentation.
less than 100.
And documentation,
Okay.
yeah, but we're close.
So you were only off by about 915 hours.
900.
On your estimate?
Yeah, all the 419 hours.
Yeah.
Yeah, that doesn't count.
Yeah, we were told they didn't count.
Yeah, you're right.
But yeah,
That's
so
fine.
we're close-ish.
But we're talking 2,000 hours.
Yeah.
Over.
Yeah,
24.
More than
2,200.
Yeah, that sounds about right. So excuse me,
So $10 an hour.
yeah,
Or $12 an hour that you can make a Dairy Queen.
okay.
We're talking California minimum wage or?
So that's
In Austin.
essentially 500 hours a student.
In,
Plus.
well, yeah, plus.
Okay.
I'm,
About 5.
yeah, I'm about 800.
And that's
Roughly
both
one person here.
419 and 420, right?
Yeah, so, and so far, that's
So that's a quarter of a man year each.
Yeah, 2,000 hours is a man year.
so,
So you put a man year of effort into this project.
well, doing
On top
full-time
of-
course load,
Yeah.
and we all work at least one job apiece.
And what are you saying? Okay.
Yeah, it was worth
While
it.
also working another man.
Yeah,
It's always worth it when it works, isn't it?
yeah,
Okay.
that big payoff.
Now this is what I want to
So,
know.
this is the cool one. We are currently
$7 under budget.
$7.86 under budget.
Well, at least I didn't go over budget, so.
There you go.
Yeah, so total spend so far is $3,896.92. If you wanted to recreate this one time, it would be about $3,540.
Yeah, I don't think we're going to get major reductions in scale. What is the cost driver in that $3,500? Cost of the wood?
Physical prototype materials.
I mean,
that's
you got an air
happening.
conditioner that was, what, $500?
Yeah, based,
Is that the biggest
Basically.
expense item?
that was one of the big ones. The routers.
So big
that was a
volumes
little
might be
bit
able to get the electronics and PCBs down some.
Yeah, but
Yeah.
that's,
that we used.
The
So we
HVAC
used
was
some premium items like all metal gear servos so they don't wear out and stuff like that, where it was a little
Yeah.
bit more expensive to buy the right thing.
but single item cost, it was the air conditioner, no doubt, right?
It was a
Yeah.
7th of the total.
Yeah, 7th of the total.
What's that?
It's about a 7th of the total.
So that was.
Materials.
But is there any other $100 item?
Cameras were pretty expensive.
Oh, come on, they're $20 a piece.
$20, $30 a piece times.
Yeah.
We've got 6 right now, plus the memory cards to go inside of them is a little expensive. Everything kind of added up. Then
Does that include the
Yeah.
cost of the wood as well?
Well, I guess when you look at
It
your
does.
populated 5 boards too, that's not a normal type of cost that you see.
Right, and this was used in places like advanced circuits.
Okay.
Well, advanced circuits in addition to silver
But
circuits.
you got $8 left, huh?
Got $8 left.
Nearly.
You can buy a pitcher for $8.
You can?
Okay.
So we're gonna be at zero.
Sunday nights is
Zero,
half price
yeah.
pitchers. You might even be able to buy 2.
Okay.
Okay.
Don't ask me how I know.
What else you got?
Go to the next slide. Here's our
Yeah.
cool full scope functional prototype.
Under
Under
budget.
budget.
Make it bold.
It is bold.
And then we have like our reflections, just
Some parts of parts.
it was a lot of, it's a pretty good challenge. And we lost a team member over the summer.
Yeah.
He decided not to join us. We picked up Jacob from another team, so that was pretty cool. He's like integrating him has been like a different kind of a challenge. So it was cool because he had to ramp up really fast. He took over a test engineering position. We lost our hardware engineer, so I took over hardware engineer.
And I took on the full weight of the construction.
Yeah,
Because Nina was supposed to be a good help in that.
Yeah.
so it was a
Didn't
lot
have
of you.
Balancing that.
And
Yeah.
those kind of things will never happen out there in the real world. Just ask Professor Wells.
Yeah, that doesn't happen.
Yeah, so it's been interesting. Yeah, it's hard to catch up once you're behind. Yeah, but like all the formal project management stuff is probably what that and I don't know, just like all of this presentation experience is what I definitely take out of this. And like pushing it further, like for the CAPM and stuff like that. Yeah. Yeah, that's, shoot, I don't know what she makes, but it's not enough. So she's
Ooh, I
been
like your
fantastic.
recommendation Actually, I like both recommendations, but we don't have much power in number 2.
You're welcome to put it in our tip jar.
Exactly.
Yeah, you get fresh flowers.
But
every
number 1, that is an excellent recommendation.
Just more transparency. Be a good thing.
Okay.
Yeah, that's all I've got. Yeah. It was good.
Yeah, I went a little bit less wordy on that. The challenges were just like designing a functional and stable house. That was a big challenge.
I thought you were talking about a stable and a house.
No. I can see that, yeah. Something along with that is changing designs in the last stretch so that disassembling of the walls. That was a huge challenge that I had to overcome there. Working in the EDC while the rest of my team was working in the BIC, that was a huge challenge, is teamwork. So that's why my recommendations is, I know there's, Richard is on that one capstone team.
With the autonomous car.
And they all work in the EDC. So, for larger projects, like ours is a large project, I wish we had a more dedicated space.
But
Instead
can
of
you do that in the
physically large
EDC?
project.
Yes.
Yeah.
You could have done
I
this?
had a table, we could have got an electronic bench and a dedicated space
Okay.
for us.
Yeah.
That's something I had all semester that it was just difficult to work with.
Is there adequate, so over there, is there adequate prototyping and test equipment resources as well?
Yes, much more than here,
Okay.
you could say.
Yeah.
I mean, it is fully equipped. I did a lot of my work there.
Fair enough.
I have friends on electrical engineering that do a lot of their work there as well.
Okay.
As far as lessons learned, I did a lot. I brushed up on my 2D and 3D designing skills with AutoCAD and Fusion. There's a lot in documentation for the recreation of the project. I also, I got a little low-level knowledge of Altium and Cayenne through working with Luke and Avery, as well as overall organization and planning skills. The whole construction of the house was a big planning, of systems and when to put the walls on, when to put the insulation in. So it was a thing I learned there.
For me, challenge definitely was switching teams mid-year to a team with higher expectations. That was the PC way of wording that.
Yeah.
But I think overall, I'm very happy I switched teams. It was a much better experience the second semester, for sure. I'm just gonna leave it at that.
Okay.
Specializing in test and product integration with only one class worth of experience. What I meant by that is, so I only took 352, which was the only test related class that we have. So taking the knowledge I learned from a single 3 credit hour class and turning that into a quarter of a man year of work was challenging.
You as students, you're not getting test/validation experience in courses like 329, 359.
Not in the formal sense of doing stuff like this.
Not like that.
Not like this.
Not even,
I would say,
not even close to this.
in the sense that, if my program's not working, I
Yeah.
go work through it and try to problem solve it. Yes, but nothing like this.
It's all
I would say 352 barely scratched the surface on stuff like this.
Yeah.
So is there value in having a class that focuses?
So you're in 452?
Yeah, I'm in 453.
43?
With Tom Munns,
Yeah.
or Professor Tom Munns.
Yeah.
And it's more like this, for sure. There was a,
Well, that's the validation class, right?
it's an elective
Yeah.
that some of us can take, probably only as a senior though, so,
Yeah.
because 400 level,
Yeah, and so,
for the end kind of thing.
so one of the things that you guys have changed though, so you guys asked, and when I gave you an example of what I thought was one of the best capstone test procedures that I've seen, you guys went off and modeled off of that, which means that now we've got a more recent model of an awesome test plan that you can now go in to test anywhere and be way up on your peers in terms of being able to understand what the processes go into, in particular, in validation testing.
Yes, sir.
Well, let me ask you from another way. Having taken all of these courses, where could you see the implementation of some form? It doesn't have to be at this level, but at least get you started. Where would you see that happening?
I personally would see it in.
Don't say 219.
No. That's right. I would see it in. See, the tough part is there's already a pretty full course catalog. If there were some, it's my understanding that 352 used to be 2 courses, or something along those lines. If in either a course like that or another course there was a way that you could implement 352 helped me learn a lot about testing in an informal way, kind of. It introduced me like the theory and like the thinking behind testing, and why it's important. If there was a class where you could get introduced to like the formal side, like this stuff, that would be helpful to me, because this was like what I had to like ask and find out and teach myself about.
Yeah. But not that,
which, not that that was a
you
huge
build a
issue.
system in 359?
Yeah, we built like a system and communications back and forth, which.
But there's no test document.
It's the final project, right?
Yeah, there's no
real
test
documentation.
document. I would say, so just my opinion, I would say like 350 maybe, where you're testing a LM 741
Yeah.
for the first time and characterizing parts of it.
Yeah.
It would be a perfect fit for something like this.
That's a good point. I
Where
would.
it's repeatable for everyone.
And
I
just
think
writing
the-
it down would just
Writing it down
really
would
help
help.
us stick a lot more.
Yeah.
Yeah, if you had like an opportunity on a lower level to do the test like process from the beginning of planning all the way through to documentation and report, that would be helpful in like a single cohesive.
Yeah.
Whereas, you know,
Or in something
in
like
352, like we did a report, we didn't necessarily do a plan. And it was less formal.
Yeah, the test plan was kind of towards the end.
Yeah.
Yeah.
Well, that's something I
But I think that it was definitely
desired.
Yeah, for me at least, it was a challenge. It definitely wasn't impossible, but it was a good learning experience.
But using the example that Professor Willie provided you helped in accomplishing
Oh yeah,
what
I
you
think
needed to do.
things would look very differently if I didn't have that example to follow.
Yeah.
For sure. Another challenge that's not up there for me is I had just personally a really heavy course load of 23 hours this semester, and that provided unique challenges and just time management and stuff like that. Lessons learned, kind of like what I talked about a little bit earlier with testing and validation. As always, gained a lot more experience working on a team of people who don't always see eye to eye and don't have the same necessarily priorities.
Before you differed in opinion.
Oh yeah, and I think that's a
I mean,
yeah,
we just
always.
just
Okay.
different ways of thinking. Yeah.
Yeah, different ways of thinking, different priorities, different, you know, styles of operation. Some people like to work during the day, some during the night, you know,
Yeah.
different
So
schedules.
24 hours a day.
Some 24 hours.
Yeah.
So it was definitely a good experience. I think that's good industry preparation, I think. And then just bouncing off that recommendation, I would recommend continuing to allow a certain level of autonomy per team, kind of like team decision making, kind of allowing them to sink or swim on their own really helps in that kind of learning experience that prepares you for industry. Like as much as possible, limiting like requirements for procedures, but obviously you have to do that to an extent.
Yeah.
All right. We have a group that passed and a group that failed.
Yeah.
Okay. And we got, what, one more?
Just managing many projects, just a lot of coursework, capstone, just basic, normally trying to manage your daily life. Working with Kaya to send appropriate timing, it's kind of a challenge most of the semester. but figuring out a way to just store it on the launch pad and then send it on other intervals was just kind of like, but yeah, and then originally the problem was accounting for the data received, because it would interrupt me a lot when I would get the commands in and still trying to publish. But now that I had just sent it at certain intervals, I allowed a lot of time for incoming messages, and that really made it really great when activating the buttons. Lessons learned, I became more confident in digging into those libraries. It was really great learning the bit math. Thank you, and I really found my passion in software. So it was just something that I'm just gonna take with me and hopefully just use it a lot more. And then lessons learned, I need to make time to get carried away in code, because sometimes I would just let myself just get so involved that it's just like it could take away from other things.
I'm not sure I understand. Make time to get carried
Right.
away in code.
That would just having a good time limit, and then allowing yourself to get immersed adequately,
Like a big block of time and just
So-
fall into the project.
Scheduling large blocks of time where you could focus on code is what, is that what you're saying?
It's a little contradicting, but it would make sense to be like, okay, from this time to this time, I'm just gonna do all this just code, and that's kind of like more or less what it was. Having an end time is what I should have had mostly. And then having all the libraries in Capstone 1 helped a ton. Just I had most of the things for Cayenne in the summer, and that helped me play a lot with it, just kind of get to learn it. So for the recommendations I would say for Capstone 1 teams was just making sure that they can, one, either upload, delete, or modify their libraries in their IDE. It helped a lot. It helped me a lot.
Sooner the better.
That was never recommended to you though, was it?
No.
Never.
Well, I mean, I'm sure it was there, but yeah, it really helped, like, I guess with,
Yeah.
What else you got?
That's all we've got. So, you should expect an email from us with all these action items and anything else that we find.
Don't forget, I will post this week a place on eCampus where you guys can post your group evaluations.
Okay.
Need to get that. You need to look at the checklist online about everything that needs to be done. Cleanup, in your case.
Are we abandoning in place?
We'll see Friday.
Okay.
Yeah, so how much your cleanup in place is very dependent on Dr. Morgan.
Right.
We can take email notice on your action items. Email notice is just fine for me. The one thing that we do need to make sure that we do is that your written documentation, I am somewhat overloaded this semester with grading written material. The sooner I get your written documentation, the more likely it is that there will be something in your tube when you walk across the stage.
Can you say that one more time?
The sooner I see your documentation, the more likely it is there will be something in your tube when you walk across the stage.
Unless you deliver it too soon.
Yeah.
It's like not complete.
Which,
First to market
by the way, it's
advantage.
16 days from graduation.
Cool.
Yeah.
16 days.
But grades have to be in.
Grades have to be in
12.
12?
the 12th, yeah.
Which is
It's like the day after finals are over.
So those for the
2 weeks
people,
from today.
well, at least for the people that they are graduating, so you know.
Yes.
Yeah.
Which is,
Please remember that it is not a requirement of ours that you graduate. You're welcome to stay another semester.
Oh, good. I'm glad you let me know.
Yeah.
some of us,
You were worried.
some of us, it's a requirement of the United States government.
Minor detail.
Minor detail.
Actually, they're not requiring that you graduate. They're simply changing your terms of
Terms of my
entry.
contract.
It is
It is a large motivator.
Yep, that's exactly what I thought. About the same time in my career as you are. So you've got a number of actions, tasks to complete. Okay, so we're going to assume that those are done in a timely manner. One of the more important ones, which I hope you will take time on, is that peer assessment. And make sure that you have accurately, appropriately evaluated each of your team members in their contribution based on their tasking. Okay? But if those things happen as I hope they happen on time with your task, peer evaluations that indicate everyone contributed. There are a small number of capstone teams each semester that I put into a category called "they really get it." Okay, they have used capstone to advance their learning, their ability to work in teams, to solve open-ended problems, to create something that actually works with appropriate documentation. I would put LANA in that group. So I really enjoyed working with you. The prototype that you've created, I think, has potential for some significant impact in things that we're going to be doing in the future in STEM outreach and things of that nature. It definitely has a potential of being impactful in the other focus area we have in MXCT, which is STEM educator preparation, of which we already have 2 students. So having them continue this work in a completely different area, along with mine, should be a lot of fun. And you've met my expectations. I guess.
He's having hard time saying it.
Is this still recording?
So, generally we send them out, Professor Willie, but I think if all those things happen, they should receive a passing grade. That would be.
Who all receives a passing grade, of course, will depend on evaluations. But, yeah, I think that you guys have done an outstanding job. I'm quite pleased with everything that I've seen. I'm looking forward to reading your final report. And so y'all all got jobs lined up? I know you got a job lined up.
For 11 years at least.
The few, the proud.
Yeah.
Where are you headed?
I'm going to National Instruments to be an RF test engineer.
Cool.
I'm going to SPEA to be a test engineer.
Where?
SPEA, S-P-E-A. Their headquarters in Italy, but going to be going to California.
They're like the Teradyne of
What part of California?
San Jose, Santa Clara area.
Yeah.
So
Beautiful.
I hope they're paying you a bunch of money, because otherwise you're going to be living in a tent.
Ooh, LANA.
We're driving
it's gonna be really awesome.
2 hours each way.
Yeah, I'm excited.
And where are you headed?
I'm waiting on I have an unofficial job offer from NOV,
Okay.
working in
Really?
their early prototyping.
In Houston?
Yes, I think it'll be either I'll stay and I'll work at Navasota at a test facility, or I'll move to Houston and work there. I only have an unofficial job offer.
Yeah.
They're doing
Okay.
paperwork right now.
You know, NOV is a company we won on our advisory committee.
I set that up. Micah did that too. I don't know what happened to Andy, but he dropped off. He's technically my boss. I haven't seen him since August.
Well,
So
so there's one additional task that, well, it's unfortunate. We've tried, and it just, I don't know whether it's,
I don't know.
I've dropped the ball or what, but it is a company we'd like to see more of.
if I see him again, I will bring it up. But
Okay.
Very good.
Anything else from you all?
so our extra material, we have wood, we have
Oh, yeah,
some
yeah.
spray paint, I think, left.
Yeah.
Some paint stuff. I
Yeah,
mean,
what do you want to do with all that?
I don't
The
see.
hammer we bought and
Yeah, we-
toolbox and stuff like that.
Well, those can be given to Missile,
Okay.
but spray paint,
like unused. Yeah.
I'd put it all in a box and hand it off to Frank or Mike and ask them to dispose of it. What's the largest piece of wood you have?
We have well, you had the 2x4s you brought, or the 1x4s.
There's a couple 2x4s.
But we have like,
It's not huge.
I mean, there's the 1x2s. There's several 4-foot of those. Really
I
old
would
ones.
see if Frank wants any of it,
Okay. Yeah.
and if he does, give it to him. If he doesn't, then
So I think I would ask the question first on the, on the giveaway for materials with David. As David, if he's got a place to store it, might want to keep it for future capstone projects.
let's.
Totally. Yeah.
Start there, and in fact, I do the same thing with the spray paint. Just,
I
that
hate-
won't last very long, but that'll last a little while.
Anything like that, I hate storing because you got a whole new set of
Oh, yeah. 'cause you got
requirements
all the-
that you gotta
yeah.
meet, and I'd rather just dispose of it correctly
All right.
and buy new when you need it.
Okay, fair enough.
For like well, actually, we have a huge roll of
I mean, you can
felt
ask
underlayment.
David if he wants it, but
Yeah.
The roofing underlayment, there's a huge roll of that, because you had to buy a roll, and we didn't need a whole bunch of it.
check with David and.
Okay, you don't want any of it, though.
Unless you can tell me a reason I would want it.
Okay.
Cool. Okay. Sounds straightforward.
Very good.
I'm gonna follow you out. Thank you.
Oh, you're gonna go see about the power monitor?
Yep.
Okay.
Right now.
Alrighty. And thanks for joining us. Well,